Greetings and welcome to another episode of the Launch Space. Today we're talking about the latest news for Azure Synapse and Purview. And I have a guest host with me today, which we're great to have. Adi Polak, thank you very much for joining. Really appreciate you being here. I know you were at some other Synapse and Purview events recently. You were able to cover those. So yeah, thanks for being here. You want to tell us a little bit about yourself?
Absolutely. First of all, thank you for having me. It's exciting to see that we're having these events. So yeah, I am Adi Polak. I'm part of Brian Ben's team, and my specialty is distributed data. So, Synapse, Purview, it's exactly that topics that I'm usually writing on, sharing content, and this is my expertise. So super excited to be here today and learn from all of you and also listen to your questions because we know questions are important and this is our main way to learn new things. So please ask questions.
Great, thank you. And so we've got a great agenda going on today. We've got 6 30-minute sessions, and the first 3 are on Purview, and then we cover Synapse, although there's going to be some overlap between the sessions as well. So I call it Team Purview and Team Synapse. We're going to have the first session is Quick and Easy Enterprise Data Discovery for All with Gaurav Malhotra, and we will take it over to Gaurav so he can show us what he wants to show us.
Right. Hi, everyone. I'm Gaurav. I'm a product manager in the Azure Purview team here at Microsoft. So what I want to talk to you today is about how Azure Purview is laying the foundations for effective data governance by providing you automatic data discovery and classification. But before I go there, I want to start with some of the data that we have been seeing. As you can see, like with IDC projecting that by 2025, the expected global volume of data is going to be more than 175 zettabytes. So as we talk to customers, we learn that data is the most strategic asset. And today, yet 3/4 of that data has not been analyzed. And when we go and learn, we found out that part of the reason for that is data is spread all over the place, whether it's operational sources, SaaS sources, on-prem, multi-cloud. And in addition to that, it's hard to make sense of that data. And most of our customers today are using manual processes to do that. So that's where Azure Purview comes in. And with Azure Purview, we are laying the foundations of effective data governance by making the automated data discovery and classification part easier. So as you can see over here that we are able to scan sources, whether they are on-prem, SaaS sources, multi-cloud sources, and build this data map, if you will. And with this data map, we are essentially capturing a graph of all the data that we have discovered and trying to provide those relationships in the data so that you can essentially consume that data, whether it's a business user, a data analyst, or a data scientist. They can consume that information that's existing in their hybrid data estate. So what I'm going to be showing you live today is how very easily you can use Azure Purview to populate what we call as your data map by setting up these scanners on these different data sources. So let's dive straight into the demo. So here I'm on Azure portal and I've provisioned my Azure Purview account. And it's just like any other Azure service. And once you provision, you land onto a home page like this, and you click Open Purview Studio, and that's when you land into our web experience for Azure Purview. And here on this screen, you can see that I've already scanned across a bunch of sources, cataloged millions of assets, specified some business terms, and then I can do consumption, basically consume information from the map by searching it. But before we go into the consumption part, as I mentioned, let's quickly see how easy it is to populate this map. So what I'm going to do is I'm going to switch into this data sources view. And here you can see that what we are projecting is a map of your sources. And you can organize that by different collections, Now here I've chosen to organize that by data center. So I have a collection for North America data center. I have a collection for Europe. I have a collection for my Amazon sources. And you can create as many as you want. And you can create a collection inside the collection as well. So you have full flexibility on how you want to organize your data map, if you will. Now, in terms of sources, you can see that we pretty much support a bunch of sources today, everything Azure. We are starting our multi-cloud journey with Amazon S3. We have capability to scan your entire Power BI tenant. And then with respect to on-prem, we are starting with Teradata on-prem SQL Server, and it's super easy for you to set up these sources. So let's quickly see how you can do that. So as a customer, you would just come in and say, oh, I want to register, let's say, my Azure Data Lake Gen 2, right? So you'll just select that, and we will automatically scan to see what Azure subscription you have access to. You can select a particular storage account, or you can search for it. You can make it part of a existing collection or create a new collection and just click register. And that's how you just set up these sources. So you can see over here that I've already set up few sources in my account. And what I'm going to be doing here is kind of walking through all of these and essentially showing you that for a particular Gen 2, like let's just take the example of this particular Gen 2 account, right? So actually, let's take an example of another one that I have over here, which is a little bit down. Yes, this one. So you can see that I've already set up some scans over here. And in terms of setting up new scan, all you do is click Start Scan. And then we have full integration with Azure Key Vault. So all your credentials are stored there. We're not storing any credentials in our service. You can do test connections just quickly to do sanity checks. Then as a customer, you can scope your scans. So you can just come in and say that instead of me scanning this entire data lake, I just want to scan a portion of my lake, or you can just keep it everything checked, which I'm going to do for this particular case. Then you come and specify your scan rule set. So basically what a scan rule set is, let's just say for this session, we're just going to create a test class. You're just coming and saying that when you set up this scan, I want you to scan all these sources in my lake. And you can see we pretty much support all document file types with doc, PPT, Excel. We pretty much have CSV, PSV, SSV, JSON, Evro, ORC, Parquet, and we are starting with gzip format as well. And not only you can choose these out-of-the-box supported file types, but you can also come in and define your own file types. So you can come in and say that, oh, in my organization, I have this .cust extension in my data lake, but actually that's nothing but a JSON file. So you can create this mapping, and once you do that, you are essentially telling our scanners that if you detect a .cust file, treat it as a JSON. So you can keep all of this checked, or you can uncheck based on what you want your scanner to do. So I'll just keep this all checked. And then you come in and specify that what classifications you want to run on your data. And this is a very important piece, because as a service, what we do support is out-of-the-box classifiers. And what that means is that as these scanners are running, we are able to tag your data to say, oh, this column is a social security number, or this column is an Australia driver license number. And you can see that we support these out-of-the-box classifiers across different domains like government, financial, personal, and we are continuously adding more over here. Now, as a customer, this is very powerful, right? Because we are going to take a sample of your data. We're going to automatically classify the data and tag you to tell that whether it is PII, whether it is a social security number, whether in terms of even security, it's a common password. So not only you can use this, what we call as the out-of-the-box classifiers, and you can see that we already support more than 100, you can also bring your own classifiers. So as a customer, you can come in and say that I have this transaction ID column, let's say in my SQL database, and I can represent the semantics of that either through a data dictionary where you are essentially throwing us a file which has values of what transaction ID would look like, or you could just represent the semantics of that using a regular expression. And then when our scanners are running, they are automatically able to use that information. And if they detect that, they're able to tag that data. So really powerful from a customer standpoint. So let's just say in this case, I'm going to leave all the system classifications on and then choose the transaction ID custom classification. And then I can specify patterns on what I want to ignore during my scans. Again, regular expressions that you can specify. We do give some examples over here, and you can add as many as you want. Okay. And this is how you just come in and specify your scan rule set. Now, for every type that we support, like you saw pretty much every Azure source, we do support Amazon S3, we do ship a default. And the default automatically has all the system rules checked and all these file types checked. So from a productivity standpoint, if you just want to use the system default, you can do that as well. So let's just say in this case, I'm going to choose the one that we created. And then you're just specifying how often you want this particular scan to run, whether you want to run it daily, monthly, weekly. And again, from a productivity standpoint, we just want you to say, let's just say you say last, and whether it's a leap year, whether it's a 30, 31 day month, we will automatically calculate that and essentially run your scan. So let's just say the scan is run and already set up, and you can see that you can see the history of the scan over here. You can dive deeper into the scan to look at how many assets it discovered, when it started, when it ended. And not only you can run a full scan, but you can also do incremental scans. So the next time it is just capturing the changes. So I did actually run a big scan just for this particular demo. And you can switch, as you saw, I switched between a map view and a table view. So in this particular case, what I'm going to use is this particular storage account where I ran this scan. And you can see that I was able to discover more than 156 million assets and classify close to 14 million assets in a span of day. And this was a full scan on a petabyte scale lake. And as I mentioned, the next time when you run incremental scan, it would be much faster because it's only going to do the changes. So you saw that how easy from a customer standpoint it is to essentially come, register sources, set up those scans, and populate the data map. And one thing I do want to mention is that, as you saw, this is truly a serverless infrastructure, because from a customer standpoint, you are just configuring the connections, and we are spinning up the infrastructure, scaling it up and down to give you the best-in-class performance. Now, once you have populated the map, then you want to consume information from the data map as well. And that's where our consumption experience comes in. So again, I'm going to switch back to the home page, and this is our search box. And think of this as that we are essentially going to be the Google of enterprise search, where as you type the text, we are essentially automatically deducing the relationships that are there in our map and giving you suggestions. Now, this is a semantic search because you saw that as I typed a business term, so in this case, you can imagine that our company ran a marketing campaign, and I want to see the impact of that on sales. So I just typed sales, and the system was automatically able to deduce that what are the assets in my map that are there, what are the suggestions that it's providing. So I can hit enter at this point, and then the system is going to return me all the results with respect to sales. And now you can further filter it down by asset types, by, again, the classifications that were applied on the data, by contacts, or by business terms, right? So let's just say for this one, we want to filter it by a particular business term. So I'm going to use this market development and sales business term. And here, now I have this filtered down results, right? So this one looks interesting to me. So I'm going to go into this particular table, and actually let's find another one like this one, where essentially you can see that Now I can find all the operational metadata, so all the classifications that were applied at the table level, at the schema level, all the properties that we have captured, the business terms that were applied on this particular data set, the hierarchy in terms of what server, what database this originated, and who updated it. And then I can go into schema to look at the information with respect to what's the technical metadata, what's the column name, classifications that were applied at the column level, the business terms, the data types and descriptions. And one thing over here is that when our scanners run, they are automatically detecting this technical metadata, applying these classifications. But as a human, you can override it. So if you have the right role, and in this case, I'm a super admin, so which means I also have curator roles. So I can edit this, what the system detected. And here, once you do that, our systems are smart enough to recognize human intervention. So as you can see that this was updated by one of my colleagues, and any future scan is not going to update this. So we do keep that. And then you're essentially able to see the end-to-end lineage of the information. And we're going to dive this more in at a later time. And then you can look at all the contacts, who are the experts and owners. And then you can browse this by hierarchy as well. Now, what that means is that as a customer, whether it is structured data or unstructured data, like in this case, it's a table, you can browse it by schema, by database, by the server. And as I mentioned, that if this would have been a storage container or a file, just like you would do it in a storage browser, you'll be able to do that over here as well. Now, we are starting with these open-in experiences where if you wanted to open up your Azure SQL table in a Power BI desktop, we are going to automatically detect if it's installed. If it's not, we're going to provide you this. And once you do that, once it's installed, we will automatically create the pbits file and open this up in Power BI desktop. Now, we are working on introducing other open-in experiences as well in future that you will see coming over here. Now, again, from a customer standpoint, you can take bulk actions where you can essentially come in and say, oh, for all of these, I want to essentially maybe apply a different owner, if you will, right? So I can bulk edit it, apply a different owner, and do a bunch of bulk actions, right? So all of this is available from a consumption standpoint. So you saw that how easy it was for me to set up my scanning, how easy it was for me to populate the map. And then from a consumption standpoint, I could come in over here and then essentially see all that information. And I could consume it both from a business user standpoint by typing business terms, or from a technical user, if I know the name of my, let's say, database or my server, I could type that and search in the catalog as well, right? So all of that is available. Now, one final thing I do want to show you from a custom classification standpoint that I mentioned, right? In our management center, we have this experience for classification rules. And this is where you can see all the system classifiers that we have. And we actually have full documentation that kind of provides you information about what are these classifications. And for each of the classifications, what is the pattern that we are applying? So you can look at this comprehensive documentation to understand how these classifications are being applied in the system. In addition, as you specify these custom classifiers, you can come in over here. As you saw, like in our case, I choose a transaction ID. So you can essentially come and define that. And in this case, I choose to represent that as a regular expression. And I can specify thresholds, a minimum threshold, maximum threshold. And then I can even specify column patterns, right? And I can represent that again using a regular expression as well. So as a customer, you're just defining it, and you can create versions of this as well. And essentially, we'll present you all the information in terms of what type of match you've applied, when it was last applied, and the current state as well. So from a management standpoint, you can essentially manage all of that information over here as well, right? So I'm going to essentially now switch to, if there are any questions on this, I'm happy to answer those.
Hi, thank you.
Hey, there we are. Sorry about that.
Yes. So it was fascinating. Thank you. First, Brian, do you want to go?
There were no questions in the chat. I did want to remind people that if you go to aka.ms/learn TV, LEARN TV, you can ask questions. This is an interactive session. Also, there is a link that I'm going to share right now with all of the links and things that are part of all of our presentations. Just a moment here. Let me put that up on screen. But yes, Adi, did you have any questions or anything to add?
Yes. A personal question regarding the technology. So first of all, it's super exciting to see that we're addressing it in Microsoft and that we're helping people understand where their data is and actually manage all of it. And you've shown in the beginning how we can connect to other clouds as well to help us manage all the data. Um, I'm curious if you're using some existing protocol or some known open source to support it.
Yeah, so basically what we are doing is we are providing out of the box connectors to be able to connect these sources and kind of scan those to populate our data map. But our data map is built on top of open APIs, and underneath the hoods, we are using Apache Atlas. So let's just say as a customer, you have another source that we are currently not supporting, or we are on our journey to light that up, but you want to essentially use that today with Azure Purview. Now, because we're using Apache Atlas underneath the hoods, and Atlas is a type system, so you can create a type of, let's say, IBM Informix and start to push information into our data map. And once you do that, then essentially our experience that you're seeing over here is smart enough to recognize that, and you'll be able to consume or browse and search, just I showed you for known types, for those custom types as well. In addition, I do want to add one key piece over here. So you saw that as I was showcasing the demo that you can do point-wise connection to these sources. But what we are also lighting up for our customers to make it easy is to be able to register hierarchies. Now, what that means is as a customer, you can just come in and say that I'm going to register this management group or a subscription, and you can stop at any level. And then we will do the heavy lifting of automatically discovering what are the storage accounts, what are the Cosmos DBs, what are the Synapse Analytics workspaces underneath that subscription, and bring it in the governance umbrella of Purview, right? So we are essentially making it super easy for you to find that information in your data state. And not only we are doing this for Azure sources, but we're extending these to other multi-cloud sources like AWS, and then eventually we'll extend this to GCP as well.
That's awesome. Thank you for sharing. I was working a lot with data scientists, and they have a tendency to store their data on GitHub and other repositories. And I'm curious if this is something you might be looking at in the future, or maybe you already have something for it.
So GitHub as a source is something that is on our roadmap, certainly. So today we do not scan GitHub as a source, but as I mentioned that if you want to push metadata for that into our map, you can use our open APIs to do that, but it's certainly on our roadmap to scan GitHub as well.
Cool.
Awesome. Cool. So if I want to learn more and get hands-on with Purview, what is the best place to go?
Yeah, so essentially, you can essentially go to this particular link, aka.ms try Azure Purview, and you can find all the information about Purview over here and try it out.
So if I'm a total, and that's like, maybe slightly a weird question, but let's say I'm a total newbie to managing data, and I know there might be some governance issue in my data, but I don't really know when, what, or how to get started. Will Purview give me this? Will help me answer that question?
Yes, so with Purview, we are on a journey to provide that unified data governance, right? And what we are starting on that journey is the first piece, which is going to lay the foundations for that effective data governance. And what you saw in this particular demo and presentation that I was showcasing is that part, right? The first piece is to be able to know what data you have in your data estate and to be able to catalog that, to be able to understand that, right? And whether it is PII data, whether it is personal data, all of that information is what we are starting with. And then to be able to consume and enforce on that is something that we are working towards in future. But absolutely, yes, from a customer standpoint, this is how they will essentially get rid of those manual processes. And we've been working with customers like Grundfos, like Illimity Bank, and this is something what they have done where they have essentially gotten rid of their manual processes with Excel, which they were using to, capture the data from different sources, manually maintaining those Excel spreadsheets, updating it. And you can imagine that from a process standpoint was a nightmare. So they have essentially adopted Purview in their data estate, and they are essentially able to use Purview to scan their entire data estate and catalog and classify the data. And they're going to carry this forward towards the end-to-end data governance journey that they are on to now.
That's great. The first time I've heard about Purview was when Satya announced it on December 1st, I think December 3rd it was. And he stated that it's in public preview. So, what does it mean for a product to be in public preview from a customer side?
Yep. So today, Azure Purview, as you correctly mentioned, is in public preview. It's available in Azure portal for customers to provision, to try it out, and start their journey, right? Because it's a journey. It's not like you just provision Purview and you go to production the next day. So it's a journey to be able to identify what are the key pieces in your organization, to be able to start to scan those, to be able to start to catalog that. So that's what we want customers to do, to try it out, to see for their scenarios, for data governance, how it works and how it makes their job easier. And then as they are on this journey and as we graduate the product towards general availability, then they can go into production with Azure Purview as well.
That's fantastic.
Hey,
Brent.
we're getting to the end of this segment. I just wanted to mention, I'm sharing my screen right now, and I wanted to show a couple of things that Gaurav had mentioned. I guess we're still not. If we could switch screens to mine. There we go. Thank you. Yeah, so I put a link in the chat, but here it is as well. There's a ton of documentation on different products that you need. We also have a bunch of documentation on Azure Purview itself. We also, if you're looking for anything, the launch space, if you go to aka.ms/the launch space, they actually have all the links that you need there. And for example, if I go to Purview overview here, you'll see that there's all kinds of information here on Purview. Also, just a little bit further down, I've got Purview on Microsoft Docs. And as Gaurav was saying, this is where you can start your journey. There's all kinds of information here, concepts. There are some tutorials as well, which we'll dive into a little bit later, and some how-to guides if you're using SQL database, Data Lake, Cosmos DB, and some ways to visualize things with Power BI and a few others as well. So next up, we have, thank you, Gaurav, very much. Really appreciate that. Sumi Venkataraman will be up next. Greetings, Sumi. And she's going to talk to us a little bit about bringing business context to your data assets. So thanks for joining, Sumi, and take it away.
Yeah. Hi. Thank you so much, Brian and Adi, for that introduction. Hi, everyone. I'm Sumi. I'm the product marketing manager for Azure Purview. I'm really excited to be here and wanted to thank you for taking the time to really understand what we have to offer. With that, I'm going to, start my screen today. Let me present. So today what I want to do is, now you heard Gaurav talk about, how Azure Purview helps you to really understand what data exists and be able to, really qualify that data with the help of more enriched metadata. What I want to do is to be able to step back and define, what is the problem scope that we're solving. From a data governance standpoint, one of our fundamental learnings has been that the need itself has evolved, that the definition of data governance has changed. So for a start, what I want to do is to be able to step back and give you the perspective of what we learned when we engaged with our customers during the creation of Azure Purview. For starter, Azure Purview is a unified data governance that helps you maximize the business value of data. And what I want to do in my part of the session is to be able to help you understand what we mean when we say, business value of data and how we help you maximize that through the product. Gaurav showed this to you, and this is sort of grounding for us in terms of, how we think about this opportunity. On the one hand, he spoke about how there's a growing, exploding, if you will, volume of data that you have to deal with. But on the other hand, we also know that, our customers, and this is according to Gartner, 90% of corporations or corporate strategies will start to talk about information as a critical asset. So number one, you've got this vast exploding volume of data, but really making that data and converting it into those business insights, into those business decisions that are driving the business is the second part of this opportunity as we look at it. And this journey for us really started with the private preview of Azure Purview, where we started engaging with customers, and we started realizing very quickly that the definition of data governance had changed. When chief data officers or data teams or IT teams within large organizations especially were looking at data governance, there were two separate priorities that they were trying to bridge. On the one hand, they had to answer questions about, what data do they have? Where did this data come from? Can I trust this data? Is it fresh? Is it relevant? Is it accurate? And then on the other hand, when they tried, when they had a vast set of users, these could be technical or business analysts, data analysts, data scientists, or data engineers trying to access this data, there was the added question of, is this usage compliant? What about the number of industry regulations that I have to comply with? Where am I really stepping out of bounds? And when is it okay for them to access a certain piece of data? So with Purview, we took all of these input in mind and defined, 4 separate pillars saying, if someone were to really look at data governance, that these are the elements that we want to help them to really light up within their environments. First, we want to help them to, of course, manage that growing data landscape. Until you know what data you have and you are able to really embrace or wrap your arms around that, without that understanding, data governance is a very difficult objective to achieve. Second, there were a number of operational silos that had been created within these organizations over time. On the one hand, there were management silos. So, data stores were being managed in silos. And on the other hand, from the user standpoint, we saw that, business departments, so, finance data analysts accessing only finance data, marketing data analysts, or sales, or supply chain, or product, or even legal, right? Each of them were accessing different sets of data. And so they were coming to the board with different sets of business insights that did not necessarily rationalize. The third thing was that, we know from research that when data scientists and data engineers go in and try to generate those business insights, that they're spending an inordinate amount of time just finding, cleaning, and organizing this data. So really taking this away and creating a solution that can solve so that data scientists, data engineers, business and technical data analysts can focus on, generating those business insights or driving those business decisions and increasing their agility was a key part of this. And finally, this goes hand in hand. All of this, whether it is the management of your data estate or making it available to users across the organization, needs to comply with industry regulations. And this, given the complexity of the regulations that we're seeing, has to be at a cloud scale and has to map that entire data estate. So we announced the public preview of Azure Purview on December 3rd. We had Satya Nadella announce this, and it was our privilege to watch, so many of you really reach out and, validate what we had learned through our private preview journey. Azure Purview is a reimagination of data governance. It is created to be unified, really bringing together data from across your on-premises, your multi-cloud and SaaS apps as well. It is created, as a hybrid solution. It is created also from the point of view of helping you scale and meeting your requirements, not just for today, but for the future. And so it is based on an open architecture. Fundamentally, if you were to look at the solution today, what we enable for our customers in terms of benefits is, number one, we help customers to really, reimagine that data governance, really take those discovery use cases, those compliance use cases, and solve for them and eliminate those manual ad hoc processes that they have in place. There are companies, of course, that are a lot more mature, have data cataloging solutions, even commercial solutions in place. That being said, really understanding that data landscape still remains a fundamental need across the board. With Azure Purview, what we help customers do, which Gaurav just showed you, was to set that foundation for effective data governance with the help of the data map. So automatically, with automated metadata discovery, AI-powered classifiers, as well as end-to-end data lineage, we're able to give you an understanding of what data exists and its relationships to each other. We also announced the public preview of the Azure Purview data catalog that sits on top of the data map and really, builds on top of that effective foundation that is targeted at data consumers in the organization. Your business and technical data analysts, your data scientists, your data engineers can come to the Azure Purview data catalog to easily discover data. And that's what I'm going to spend a lot of my time after this on. And finally, with the help of the understanding that we have of your data estate, we're able to unlock never before seen views of your entire data estate. It's breathtaking when you can look at your entire data estate and be able to tell where compliant data exists, or how data is getting used, or what is the kind of business usage that you're able to drive with your data. Azure Purview, from in terms of how you interact with it, at the heart of it, and I'm going to be very quick about this because Gaurav explained it as well, is it's got your data map that connects all of your different data sources. Sitting on top of this data map is the data catalog, again intended for data consumers, and on top of the data map, again building on top of that understanding, are data insights that helps you assess data usage across your organization. But at the heart of it, when you talk about maximizing that business value of data, it really starts with how you define or how you enrich your understanding of that data. Towards that, Gaurav gave you a quick sense of what we help you to unlock. But just to summarize that so that we can talk about this in much more detail, we believe that there are 3 key dimensions when it comes to defining that value of data. First, there is the operational metadata. This is what sits in those stores, and it helps you administer in terms of, this is the information you need to manage a data set. With Purview and its automated scanning, we're able to, number one, get that existing metadata, and then we help you to complement it further. This ensures that that data can be more easily managed, but also more easily utilized by your data consumers across the organization. The second part of it is in terms of the semantic metadata. This is where you attach meaning to that data, right? Like, what does this data mean at the end of the day? With the help of AI-powered classifiers, both built-in and custom, we're able to help you tell what that data should be, should mean for the organization. This could be, a classic use case is when you're defining the sensitivity of that data. So for instance, if it is a PII data, you want that called out specifically, and you use your classifiers to help you do that. We also are integrated with Microsoft 365. And so you can leverage your existing compliance understanding in terms of Microsoft information protection sensitivity labels that you've already defined, and then extend that using Purview to the rest of your data estate. Finally, and most importantly, and this, each of these builds on top of the other, which is in terms of your business metadata. Now, I spoke to you about the silos that were created, finance, going after finance information, or having a finance worldview of what data means and a way to address that data. So for instance, revenue could mean something for finance, but it could mean something else for marketing. And just that term could mean something else for sales as well. And so when you want to ensure that your data is used across the organization by a variety of data consumers coming in from very different perspectives, you want to make sure that they're able to interpret that data uniformly. So there is a process of rationalization, and many of you have already started on this journey with data dictionaries that typically, we've seen exist in multiple Excel files or even existing catalog solutions, which define to some extent what these business terms are and tries to rationalize it across the organization. But within Purview, we have a business glossary that helps you to really do this or define this vocabulary for your business users across the organization. And we take this information to complement the experience that data analysts have when they log in to the catalog. So when we talk about this spectrum of, there is an existing value to data and how can you really maximize that business value, it stretches along the spectrum where you define how you can, more easily manage it, what is the meaning of that data or what is the value of that data, and then complement it in a way that it can be maximized by business users across the organization. Here, I want to, quickly before going into the demo, I want to show you how this lands within the product itself. So here is a screen that shows you, the search result as your data analysts come into that catalog and search. As you can see, the semantic metadata, the operational metadata, and the business metadata are an integral part of the experience that we unlock for them. Your business glossary itself is a set of terms or business terms and definitions that you can steward looking across the business, looking at those different terms, their interpretations, and then rationalizing them with the help of one business glossary for your entire enterprise. Finally, there is, you can attach this vocabulary to assets in the catalog. So it ties back to those data assets that you have discovered across the organization. You can understand, what is the business context with the help of descriptors, with the help of, association within the catalog itself. And then you can bulk import or, get a running start by importing business terms from existing dictionaries. And finally, you're able to really define by domain what are some of the essential attributes that need to be defined as part of a template. So imagine that if you had business glossary terms that are owned by the finance team, and the ones that they're defining, the custom attributes that are required to complete that definition for that term can be grouped together into a term template. So for example, taking forward that finance example, if you were to say that, every finance business glossary term needs to also mention what is the cost center, what is the, what are certain ID information that needs to be associated with that. You can do that with the help of term templates, basically helping you to scale, but not lose the value that's associated with each business domain. With that, let me switch over to a demo where I can show you some of these things in action. So here we are in, I hope you can see my screen. We're in the Contoso Purview. This is our demo environment, and you're looking at the home screen of the catalog. As Gaurav spoke about, we've already hooked this demo tenant up with a number of sources so that you can see for as close to real an example as possible as to how this really lights up. Now, in this case, I'm an admin, so I'm able to see a lot more. You can, of course, customize the experience that your users will be able to experience when they log in here. Now, when the important thing is, that when we're looking at a variety of users coming in from different perspectives, even just thinking about that search experience is really important. Being able to be inclusive of, the different viewpoints from which they're coming is important. So Purview does this with the help of a semantic search and browse. So in this case, if I were coming in as a business user and I were to type, sorry. Okay, we're back. In this case, I'm typing a term called customer. And what I'm really looking at or looking to find is a set of customer data that is specific to my need. But when I come in and search over here, I am met with 105 results. To make sense of this, we guide users and help them to really narrow in on what is the result that's most relevant to them. And we do this with the help of operational metadata. They could decide, what is the asset type that's related to this. Semantic metadata with the help of classifications. We have contacts as well. So imagine in a typical situation, you would have certain folks that you know of within the organization who you know to be the subject matter expertise or subject matter experts of that particular search result. But here what I'm going to do is I'm going to look at the glossary terms, right, as a way to ground myself. And I click on customer again. And I can see that out of 105 results, I've now suddenly gone down to just 4. Now, within this 4, I'm going to click into this customer table, and I can see immediately as a business analyst, right? I can see immediately that there's a lot of information here that can help me to do 2 things. One, it can help me to guide me to say that, hey, I am at the right search result, or this is the destination that I was looking for. But also importantly, and this is a lot more subtle, be able to trust the information that I am interacting with, right? In this case, I'm able to see a bunch of information here related to, the classifications, etc. I'm also able to see, who last updated it. In this case, it's our next speaker. And then, we're able to see the hierarchy, but I'm also able to see what are the other glossary terms that are associated with it. Now, I know that I'm on the right path when I can see that these terms correspond to the intention that I had in mind. I can further go to schema. I can look at the lineage, etc., all of which, promote that both the interpretation as well as the trust associated with it. I can see who are the contacts, and I can see other information that are related so that, if I were, say, a technical data analyst, I would be able to interpret this information and carry on, much deeper analysis if I so required. But let me, talk. I showed you how the business glossary shows up in action. What I really want to show you is the glossary experience itself. Now, here I am in the glossary tab within the Purview workspace, and I can see that there is, these are there are a number of terms here. You can easily browse through them. They're listed alphabetically, right? But let's see what it would take to maybe create a new term. Right. When creating a new term, I'm first asked to select a term template. This is what I told you in terms of, being able to really guide what that perfect definition of a business glossary term looks like, right? This is your ability, say, as a data administrator or a catalog administrator to say, hey, whenever there is a term defined, I want it to be qualified by these annotations over and above what I'm able to pick up or what I'm able to define within the system. So you can really bring in those data stewards from across the organization and channel their business expertise to define a more meaningful business term. In this case, I'm going to select the system default, but as you can see, there's a number of custom templates that are term templates that have been defined here. Once I go in, I can define a number of things to qualify this further. What is the name of this term? What is this definition? Acronyms really help ground in the way that analysts across the organization would probably refer to that term, as well as other resources that can help guide folks who are searching for that term to understand what this term really means. Importantly, and this is something that is, perhaps an understated need, which is that, there may be synonyms. People may search for a term with different words, but associate that back with the business glossary term helps ensure that, when they search for information, they're able to get to the right result. And finally, there are related terms as well. So if this helps you to associate other business terms that this business glossary term is related to. Again, this guides not just the business user, but also helps them to trust it more. And then finally, you can explicitly mention who are the stewards and who are the experts who need to weigh in on the definition of this term. You can manage your term templates as well. Again, you can use, we have a template that we offer you in terms of, the term templates itself. So you can choose to use the system one, or you can choose to define your own custom templates. Because every business is different, every scenario is different. We highly recommend that you take the time to invest and create those term templates that work for you and can really help your business maximize that value of data. With that, I'm going to switch back. We have some, so just a quick recap. We spoke about the business problem that Purview is trying to solve overall. We spoke about, what we mean by business value of data. And I also showed you how we help you to maximize that business value of data. We have some exciting news coming up, and, we'd highly urge you to please, join us at Ignite to get a lowdown on what we're going to announce. Ignite is on March 2nd to 4th, and you can go to ignite.microsoft.com and, just sign up for one of the sessions on Purview. We look forward to meeting you there, and we look forward to communicating, a lot of the great news that we have landing there. With that, I want to hand the mic back, and I want to thank you so much for this opportunity to talk to you today.
Great. Thanks. Hey, just to add, you mentioned Ignite. Ignite is free this year. Yeah. Usually the in-person event is, there's a fee, but Ignite is online and it's free. So please do check that out. Just search Microsoft Ignite in your favorite search engine and you'll find it and sign up. There's our great sessions on Purview and of course, many, many other topics as well. So Adi, did you have anything to add regarding this session?
Yes, Sumi, first of all, thank you so much for walking us through it. I just want to mention that we just got a glimpse of what's coming up in Ignite. So in case you missed it, right? Yeah. So there's going to be some great announcements, so that's exciting for us to get a glimpse before everyone else. So yes, we have a few questions. The first one is there a way for us to automatically set the business terms in the Purview catalog, in the Purview catalog?
Let me see if I can understand. Do you mind, just elaborating a little bit more on that?
Yes. So can we stamp this business terms that we use, that we have in the catalog, in an automated way, so we won't need to redo the computation or redo the calculation of the data map itself, or if you want to search for specific terms, is there a way for us to have that automatically without the need to maybe go and create a new templates every time from scratch?
Yeah. So the once you associate it with the data asset, that's a really easy way to ensure that it's always up to date and associated with the latest data. The other thing is that the term templates really help you to define what those terms are, and then really qualify everything around that piece of data that's required for the broader set of users to be able to go and use that business term effectively.
Cool, that's awesome. Another question is, can you import existing data dictionaries into Purview catalog?
Yep, you can do that, and you can, whether it's an Excel or CSV file, you can import those data dictionaries into Purview, and you can get that running start. In the meanwhile, we have great documentation, something that I couldn't cover and I forgot, so I'll drop the link. But you can, if you were to search for that, it has instructions, step-by-step guide that can help you to import those data dictionaries.
Awesome. We love guides. All right. Another question is, you've mentioned that Data Purview helps with data governance challenges. Can you give an example of a challenge that you've seen and how it helps solve it?
Oh, well, that's a great question. And I think, like Pratik, when he comes on next, is going to talk a lot about that compliance scenario. I'm going to let him take that question.
All right, noted.
That might be a good segue. So also I wanted to add, for anyone who has any questions in the audience, please go to aka.ms/learntv. We're live there right now, and we're taking questions. And also on aka.ms/learntv, I posted some links, some relative links for Sumi's presentation on the Purview docs, and also a link to our overall page, which shows you all the links for everyone's session. And that's where we'll be posting the slides and the live videos when they're out later if you're watching the recording. So with that, I just wanted to go back to the agenda if I could. And just mention, thank you very much, Sumi. That was wonderful. Thanks. And next up, we have Pratik Verma. Pratik is going to be covering governing your data from origin to consumption. And Adi actually had a question for you, which will likely be answered during the presentation, or you can take it now, whichever you prefer.
Fantastic. Thanks, Brian. Are you able to hear me okay?
Yeah, everything's good. I can see your screen as well, so thanks.
All right, fantastic. Really excited to share. My name is Pratik Verma. I am a group program manager inside of Azure Data. I work with Sumi and Gaurav on Azure Purview as well. Now, Sumi and Gaurav covered a broad ground on Azure Purview as a whole. And so you'll remember this slide from Sumi's presentation about how Azure Purview is reimagining data governance. Now, for the data estate management inside of Azure Purview, we'll focus in on my conversation on the first two, middle two sections on the slide. The first one is about setting the foundation for effective data governance, and another one is how do you maximize the business value through end-to-end lineage. That's what we'll cover today. Now, you've also seen this particular view on Sumi's and Gaurav's slide about how we envision Azure Purview Our aspiration with Azure Purview is to allow our customers to manage their data estate entirely for their entire data estate, starting from databases on-prem to data sources on multi-cloud environments to SaaS applications, all through the actions of the data map, which is the foundation of the data governance. Now, this data map contains a graph of all your data assets anywhere in your data estate. And it does so, it represents your data assets in sort of two foundational ways. It represents it as a graph, which contains nodes of data assets that are connected to other data assets through lineage arcs. And then you can assign tags to individual data assets, from a variety of different lenses, be it business metadata, operational metadata, technical metadata. A lot of screenshots and the demos that you saw from Gaurav's demo and Sumi's demo earlier. Now, the whole perspective that Azure Purview brings to the table that's unique is the idea that you can cover your entire data estate from the origin, where most of the data assets are sort of captured in your on-premises data sources like SQL servers on-prem, SAPs, all the way through to Azure and to BI tools. Now, the data map powers the two experiences on top. The first being the data catalog, the other being the data insights. The data catalog gives your data engineers, data consumers, the ability to interact with the data map from a non-technical way or non-programmatic way. But data insights also give you the ability to see the estate as a whole from any of the lenses that you may how much the business glossary management is covered across the entire data estate, whereas a security administrator may be interested in what kind of sensitive information is present in which systems. Now, for the purposes of our discussion right now, what I'll really sort of drill down in on is how does Azure Purview automatically capture the lineage of data as it moves from the source on-prem all the way through multi-cloud to Power BI on consumption side, and how all of that is powered automatically so you can actually do the job of tracing and trusting the data all the way through. So this view kind of gives you a view of what I just kind of summarized. Now, Azure Purview is the one unique thing that allows you to span not only the data sources on-prem, but also in the cloud holistically. It's the first platform as a service offering for managing data governance, which provides you the single pane of glass. So let me orient us. So on the far left, what we've shown here is data sources on-prem. These are your SQL servers, your Teradata's, your SAPs of the world, where a lot of operational data gets collected. Oftentimes, if you're doing digital transformation, you're ingesting that data into the cloud using a variety of tools. One tool that we really love is Azure Data Factory. It allows you to copy data into the cloud very easily from lots of different sources, land it in cloud storage in the landing zone, and then through the operation of a variety of different query engines. Let's say your ETL transformations inside of Synapse, or Spark notebooks inside of Synapse, or consumption in Synapse. Maybe you put a little bit of SQL on top. Maybe you put a little bit of Cosmos DB on top to handle your data sets in kind of a NoSQL way. And at the end of the day, you kind of enrich the data sets. And the landing data sets eventually get consumed in lots of different modalities through lots of different users. So one example would be I share a Power BI report that is powered by a table in Synapse, which got generated from a file in SAP that was ingested through Azure Data Factory into a CSV file in Azure Storage. So you can see kind of all sorts of things are happening to the data sets as they're moving from origin to consumption. Another example would be a cloud native app where you're building a mobile application that's powered by Cosmos DB in the backend because you want to be able to give fast responses back to our users. Another example would be you've created a file, you've enriched it, you've done some transformations using our query engines, and now you're trying to share that as an extract across your tenant or across different data sources. So as you're using all your environments for managing your data estate, you may have the tools itself may change in any of these blue boxes, but the net kind of pipeline from data supply chain from source to consumption, falls and looks something like this. Now, this is what Azure Purview allows you to keep track of as data moves from the left to the right, gets more from the origin, kind of raw form, all the way to consumption form on the right-hand side. So that's what we're going to drill in onto our demo. So let me switch over to Purview Studio. So this is something that should look familiar to you based on what Sumi just shared with you. Now, I'll do one click before. Now, the good part is what Azure Purview is replacing is a collection of box softwares, 4 or 5 of them that our customers gave us feedback that they're currently using when they hadn't had Purview yet. They were using a lot of business process to manage their infrastructure, using a lot of business process to manage the data management aspects of governance and everything else. So with Azure Purview, what you're seeing in Azure Portal right now is a data engineer or a cloud administrator that has provisioned an Azure Purview account for consumption and use by lots of business users in one place. Now, I'll highlight 2 specific things. This is a platform as a service offering. So unlike box software where you would have to maintain the infrastructure, the VMs, and then buy licenses of software, then install a bunch of components together, you don't have to do any of that. It's all covered underneath the covers. We are using underneath the covers Cosmos DB, Azure Search, Kubernetes, and all the goodies that allow you to take advantage of the cloud native scale without the infrastructure headache of building all that yourself. Now, the one thing we'll drill down here is into Purview Studio. So once Purview has been provisioned, most of the time your end users, be it business users, data engineers, data scientists, will be going in and interacting with Purview using the Purview Studio. Now, let's go drill down into Azure Purview Studio, and this will become kind of familiar to you as well, based on kind of what Sumi shared. Now, oftentimes when I'm looking for my data estate, what has happened already in this particular Contoso Purview account is we've connected it to 116 some data odd sources. These are, a variety of different data sources in our demo environment. We've also cataloged about 5,000 data assets. An asset would be a file or a table or a data set inside a Power BI report. Those are individual pieces of data sets that are somehow related to each other through transformations or lineage arcs or data movement motions as well. So because you're already in here as a data user or data consumer, I may be coming in and I may be saying, okay, I'm looking for business, doing some sort of marketing analytics. So let me find data sets that belong to customers. So I'll say, I may also need some finance information to keep track of, how many different customers are using how much of my product. So let's go search for that. And what we're landing on is a list view that kind of shows you all the different data assets. Now, what's really natural next step for me is to figure out, okay, let me hone in on a data set that may be of interest to me. So I'm going to go in and I find this customer table. This looks like it's kind of a sales data set. It contains email addresses. So I'm going to go drill down on it. Now, once I drill down on it, Sumi shared a little bit about, all the different information a user can find out about it. But my first question comes in is, this particular data source happens to be a table inside of SQL Server. Where did it come from? Like, how did that data set actually get generated? And can I really trust it? Where is this data set actually being used? What else other things are these things sort of populating? So to do that, it's very easy for me to go click directly into the Lineage tab here to go view the lineage of how this particular data asset is being used across my system and how it came to be in one place. So let me sort of focus us in on that. You notice that on the pane I opened up, I kind of zoomed in to the lineage graph. I can zoom out. This allows me to really visually traverse different aspects of the data asset so that I can zoom in and kind of really look at, evaluating kind of how this data set is being utilized. So let's take a look at a couple things here. What we noticed here is this particular SQL table, I looked at it as part of the overview. I noticed that this contains a few columns. So let's go take a look at this. I'm going to look at that. This table contains a bunch of information like, company ID, email addresses, first name, last name. It's got a couple passwords. So let's pick, kind of a couple columns to highlight, what the data sets are that are contained inside, which fields are contained inside of a particular asset. Now, if I were to zoom out of this, I can now, through the lineage graph, see that this particular SQL table is being utilized in 2 different data sets downstream. So you'll notice, remember on our previous graph, chart we saw, a SQL database on-prem powering some of the data sets through ingestion into a cloud store. So this is an example where using Azure Data Factory, what we've been doing is copying this SQL table into 2 other downstream resources, data assets. First is a customer credential table, which has a couple of fields removed. Another one happens to be a file inside of Azure Cloud Store. And what you're able to see is through various ETL transformation in Azure Data Factory. So let's take a look at this particular one. We are able to track that there have been data movements and copy movements happening underneath the covers behind the scenes. In this particular Data Factory instance, the Lineage demo March 2020, in that particular Azure Data Factory instance, there's a particular data pipeline that is executing. The logic inside of that pipeline can be visualized in the Data Factory when you go switch to it. But that transformation is taking an extract of the data from one SQL table and copying it into another SQL table. And in the process, it's removing the password hash in this particular credential. Now, you'll also notice that at the same time, another data asset is being created through one or more transformations. So in this particular case, there happens to be 2 different transformations with 2 different pipelines that are generating another extract. And in this particular file extract, you are actually taking the password hash and continuing on forward. So this allows you to keep track of how the different data assets are grouped together in the different data systems. Now, this is one specific shot of the view. Now, let's take a look at kind of the earlier part of the funnel and then the end of the phase. So let's go back directly to the source, the origin, if you will. So in this tab, I happen to have a Teradata database, which is on-prem. And inside of this Teradata database, I have a particular product data set. I can go drill down. I've already configured this for scanning. So this happened to be scanned last August and happens to be on one of the data sources on premises in this particular table. If I look at the lineage of it, I can see that this data assets is being transformed within Teradata itself. And I've created 2 different result sets that originate from this particular Teradata table. So what this is showing you is Azure Purview's ability to go drill down, focus specifically in the data source itself that has been configured for automated scan and classification, and capture what's happening inside the particular Teradata table itself. Then, if that data set is being copied from this Teradata database or a SQL database to another data source in cloud, through the movement of Azure Data Factory, you're able to see that view itself. So you're able to see the transformations that are carrying a table from the origin in the SQL table to other downstream applications, in this particular case, another SQL table and another file. And more importantly, let's go look at, we saw the origin, the lineage within what's happening inside of the system. We saw how the data set is moving from one system to another. And let's take it all the way to consumption. So let's take a look at another example where we have a Power BI dashboard. So on the right-hand side, what I'm showing you is a Power BI tenant that has been configured for scan to this Azure Purview account. And we're seeing that this particular report, dashboard that is being seen by hundreds and hundreds of people inside of your company, is actually powered by a finance report. So it's one of the measures inside of the report is being powered by this Power BI report, which is sourcing data either through direct query or through automation, through local query, inside of a data set from somewhere outside of Power BI. And those 2 things happens to be a file inside of Cloud Store, Azure Data Lake resource set, and a table inside of SQL database. So using this lineage arc, you notice how we're building up these lineage arcs all the way down from origin in Teradata SQL through transformations through Azure Data Factory, through connection to Power BI data sets, all the way through, so you can notice one very specific thing. How did this Power BI dashboard metric come from, all the way down from that table in SAP on-prem? That's really cool and fantastic. So that's kind of what I wanted to share here. There's a couple other things that you may be thinking about. You're going to say, well, this is all fantastic and good, but then how do I kind of use it beyond this particular data sets instead of just making, a particular pretty graph here? And isn't populating and creating this lineage graph really problematic? Because most other tools out there, ETL transformation tools or other catalog tools, force you to have to create and populate that manually. So here's where we're going to go in and jump into a couple, neat tricks here. So you'll notice that I looked at this particular Power BI data set and I said, oh, it's originating from this particular data source. If I were to switch to particular data source here, I can then pivot around this particular view to see what other applications and downstream measures are being connected and originating from this particular file itself. So in addition to that particular dashboard, it turns out that there's a lot more other reports that are also powered by the same data sets. So you can actually find other data sets that you can trust if you trust this particular data set. Or if there's an error in one of these data sets, you can propagate that error all the way through. So you can fix it. And then after you provide the fix, you can basically make sure that all the data sets and the impact of all downstream data sources is measured and known to your data engineer. Now, you know what I said about, how does this actually get populated all the way through? So it happens from a variety of different sources, but there's only three main things you have to worry about. Let's go jump into this particular view. You've seen this on Gaurav's chart about how we scan and configure a bunch of data sources for management. So in this particular scheme, what you're seeing is a Contoso data estate. It's broken down into just sort of three logical units: the data sources on-prem, the data sources on Azure in the cloud that are doing the enrichment, and the data sources that are, being where the final result set of data sets are being consumed. So you'll notice that, we walk through Teradata, SQL Server, Cloud Store, Power BI, and we saw kind of how the lineage was connected to all the way through. So when you register a data source, let's say a SQL Server or Teradata data source, when you configure it for automated scanning and classification, you're capturing not just the metadata, but also stored procedures, and also how those stored procedures are creating other data assets together. Now, we covered those for a subset of the data sources today. Over time, we're going to increase the number of data sources that we are going to provide you scanning for, so you can capture the lineage and the metadata from all those sources from within those data sets itself very quickly and easily. So you can sort of capture that. Now, the same thing happens on Power BI. Just by registering Power BI, you'll be able to see all the lineage between different artifacts inside of Power BI, plus the ability to connect the data source from the Power BI, the data set from the Power BI, will be able to link across to the files inside of Azure Data Store when you register both the Power BI data source and the Azure Data Lake Store. So the step number one is basically bringing under management of an Azure Purview account all of your data sources on-prem, all of your data sources on Azure Cloud Store, and all your data sources in Power BI, so that in one place, you are able to see the three steps of lineage within Teradata, across data sources, and all the way through the consumption. So you can build that lineage all the way through. Now, the one last thing you'll say is, great, that is fantastic. How did you figure out this particular transformation? Now, this ETL transformation is going on. So how did you actually capture that? Because, how does that show up in this particular view here? Because it's Azure Data Factory moving the data source from one to another. To answer that, it's very simple. You go into the Management Studio, go into the Data Factory tab in the external connections. And once you've done that, any and all of the data sources, the Data Factory instances that have been registered into this particular Azure Purview account will emit lineage directly into this data map automatically, so you don't have to manually do that. So you'll notice that this particular lineage demo March is what was registered previously, And this is what is allowing us to look at the transformation that connects this table to this particular table that is moved after transformation. So through this action, you are able to create an entire active metadata graph of your entire data estate without having your data engineer to go into each system by system, then connecting them through manually populating the lineage arcs, making sure that they're current when transformations happen, when ETL pipelines change. All those transformations are being captured directly. And it allows you to capture the view from the cradle to the consumption of this data set. So that's really sort of powerful. Now, what you'll notice again is on this particular view, we're showing you, a lot of data sources today, a bunch of data sources from Microsoft on Azure Cloud for SQL Server, a bunch of Power BI. We're showing you Teradata. And as Sumi mentioned, we have the ability to add other data sources like SQL Server, like Amazon S3, like Cosmos DB, like Synapse, and so on and so forth. And we're always increasing this list as we go along. Now, there are going to always be scenarios, ETL tools, transformation tools, Spark query engines, or things like that are going to be, covering in portions of your data estate, which, may not be something that we're building in ourselves, or it's something that we're building, but it's longer down on our roadmap. So to address those questions, you don't have to worry about carving that and leaving that part of your data estate dark. You can go into Apache Atlas API. This is an open source API that lots of open source tools already depend on and are built to use. And these data sets in here, this API, you'll find a lot of developers already know and are familiar with this API. So you don't have to train people on a proprietary API from a cloud vendor. Microsoft has taken a very specific open approach to solving this particular problem. So we've created this. Using this, you can utilize the lineage into your other downstream applications, or you can auto-populate this lineage using Apache Atlas compatible hooks. And with a little bit of programmatic sort of elbow grease, you can basically automate the population of data insights and data reports, this lineage arcs, across from any system that may be of interest to you. So in a nutshell, what we covered today was how do we register a particular data store, bring it under management of Azure Purview, and then how do we basically automatically capture lineage from origin through across the hybrid to on-prem, from on-prem to the cloud divide, all the way through from analytics enrichment to the consumption zone. So with that, I'll switch back to the slide here to cover on, how do you get started? So we covered a fair bit about Azure Purview in action to the lineage all the way through. We'll notice here, there's a couple points I want to hit back again. We saw the power of the data map in action here, where you can connect a data source, whether it's on-premises or clouds, into the data map. The data map allows you to connect and register and bring a data sources under management of an Azure Purview account, a set of system, your entire data estate, either through automated crawling or scanning or through APIs, where you can capture all the lineage through the entire chain in one place automatically. And once you have that, you can then enable your business users to use that automatically without having to learn API code, without having to learn kind of programmatic things, without having to learn how to manually update it and always keep it up to date. So you can use it to make sure that the self-service of data discovery is easy. Now, the last thing I want to leave you with is an insight on how we're thinking about why Microsoft is the unique sort of cloud provider that provides a PaaS governance offering to you, and why you should go with us. Now, the interesting thing about here is we happen to have within Microsoft one of everything. So we have a SQL Server on-prem. So you're using a lot of our SQL Server for operational databases. You can bring that under management of Azure Purview, fully integrated already. You're using a lot of our Azure Data Services, operational analytics systems, your Cosmos DB, Synapse, your storage accounts, your GW accounts, your Custo accounts. So you can bring them all under management of Azure Purview. And finally, you can connect it to Power BI and Power Platform and bring them under management of Azure Purview. So if you're using a lot of our product, you're going to get a very unique fully integrated view of Azure Purview and your data estate from Microsoft as a whole. And in addition, you saw that we brought Teradata under management to a similar extent as we did SQL Server. We will be adding that to Amazon S3. We'll be adding that to Google Clouds. We'll be adding that to other data sources on, from Microsoft, other cloud vendors, or database providers. So keep an eye out for what Sumi will share with us, down the road around Ignite and more. So with that, I'll close it off with saying, you saw a lot of things today. The first thing you should be able to do is go into Azure Portal, provisioning yourself an Azure Purview account, connect it to your Power BI tenant, connecting your SQL Server on-prem so you can replicate what I just showed you today. And by the way, the one awesome thing is, if you're using Azure Purview and you're connecting Power BI and your SQL Server on-prem, both of those scanning for those are free so that you're only paying for the data map. So this, really take advantage of that. So with that, I'd like to thank everyone for, your attention.
Hey.
Brian, back to you, sir.
Yeah, thanks. And Adi, thank you very much. That was great. We do have some questions. Adi, do you want to go with the first one? I'll follow up.
Yes, well, I think, Pratik, you already answered it, but let's make sure, everyone captured how you do it. So for business analysts, one of their main tasks is to create an impact analysis of how, kind of a study of the business activities, where the data goes, how the data flows, what are the different pipelines, ETLs that they're building, that the organization creates. So maybe if you can remind us again, how can we check it out and how it can help us with the impact analysis that we want to create?
Yep, exactly right. Now, the one, this is the screen I would go back to on my screen where I'm showing you kind of a view, an example of the customer table in a lineage graph connecting a particular SQL table to another downstream applications. So one of the things you can see in this one particular case is, if I'm looking at a particular data source, I will know where did it come from, and I can go traverse to a particular switch to a particular data asset and see what the impact is to a particular downstream data set from an upstream data set. And I can drill down into, what are the criteria and different tags that are applicable to it. And if I were to go back to the lineage graph, I can see,
yeah, go ahead.
I
just want to break in. We can't see your screen right now. If you could, we need to put the screen up there just a moment. There we go. Thank you.
Okay. How about that now?
Got it. Thanks.
Awesome. Good. So in this particular case, let's say if I'm sitting into this credential removed SQL table, I can find out what is the impact to an error, let's say, in a record inside of this upstream customer table through the actions of this lineage arc. Now, what we're really excited about this is we've set up this foundation. What we want to be able to do things like is, for you to do a traversal of this entire lineage, not just through interactions with each other, but through automated propagation. So imagine having a tag on this particular customer table, which is, let's say, if I go to switch to this asset, imagine having a tag that says this contains email addresses or a person's name. And if it's being carried over into any of the downstream applications, we want to be able to have those tags be automatically applied to those tags as well. So those are some of the activities and other goodies that we're going to be building in to this lineage thing to make the impact analysis workflow a lot easier and simpler for our customers. Today, you can see how that entire data set is related to other data sets in the entire graph, which is automatically populated, which already, if you're familiar and you're a practitioner of this, you'll notice it will save you human capital in terms of creating this graph and creating this sort of lineage assets automatically in one place.
Cool.
Yes, the no-code, low-code approach here is great.
Fantastic.
Hey, I wanted to share my screen as well, if I may. For those of you who are watching this, either recording or live, aka.ms/the launch space is where you can find all of the links that we're going through today. But specifically, I wanted to show you this one, something that's relevant, something I just shared in the links. There's a tutorial, which is a great way to get started, scanning data with Azure Purview. And it actually provides some simple data. So you can go in and you create a data estate There's a starter kit that you run. And then there's some data that you collect to run the scripts, verify permissions, boring stuff, and run the client-side scripts to get that going. And then you actually scan some data into the catalog and use manage identity to add to authenticate to the storage. And then there's some data sources you can actually scan as well and register and scope your scan. So it's a pretty good tutorial, and it's all part of the documentation that you have for Azure Purview as well. And both of those links are at aka.ms/launchspace if anyone needs those. I did want to cover that real quick, and I have a quick question for you as well. Are there, sample or custom sample or demo databases or data that we can use to sort of train our models here?
So it's super exciting. If you go to the starter kit, it has a sample set of data sets and sort of an environment you can set it up to play around with Azure Purview. So I suggest you try that out. Okay,
cool. All right. Well, that's the time we have. Next up, we have Charles Federson, who's going to talk to us about building an enterprise data warehouse in Azure Synapse. So we're moving to Team Synapse. Welcome, Charles.
Thank you. Good to be here.
Thanks. I'll let you take it away.
Fantastic. Thank you. And thank you, Pratik, for setting us up with governance as we move into the Synapse component of the session today. I'll start by talking a little bit about enterprise data warehousing, a very common scenario that we're working with customers who are modernizing these platforms, legacy platforms, onto more elastic and modern infrastructure in the cloud. I'll be joined a little later by my colleagues Ewan and Savine, who are going to talk about additional capabilities of Synapse. But the key to remember, I think, as we go through this 3 sessions today is Synapse is a single unified service. And we'll all talk about enterprise data warehousing, which is probably more of the traditional workloads we would think about for this class of analytics platform. What Savine and Ewan will talk about is really how Synapse extends into entirely new classes of workloads as well, all within a single unified platform. Now, within the context of enterprise data warehousing, I'm going to really focus on 4 simple things. We've only got 30 minutes today. I could talk about enterprise data warehousing for weeks. So I've tried to really simplify this into some of the core sort of, I'd say, things that you need to look at when you look at data warehousing. One is around your architecting and data modeling in data warehouses when you move to the cloud and distributed systems, particularly if you're coming off something like SQL Server, or if you're coming from appliance-based platforms where you're familiar with distributed data models. We'll talk and look at that in a bit of depth today, and of course, look at a fair bit of code. We'll look at data security and just demo some of those capabilities and explain how some of those core functions work. I'll talk a little bit about workload management, which is another core capability within enterprise data warehouses, and how you can support very large populations of users, and at the same time ensuring that everyone's having a very predictable experience, and at the same time the cost is very predictable as well. And that becomes something that needs to be considered as you do move into very elastic cloud warehouses. And the final, I'll just give a quick demo on some of the more recent functionality we've launched around advanced analytics and how we're enabling in-engine scoring of ML models using the actual SQL language and that cluster as well. So let's get moving here. At the top, I just want to remind everyone that this is a unified experience within Synapse. The scope of the conversation that I will have today will be around the SQL Analytics runtime and the data warehouse storage. Ewan is going to talk more about Spark over the data lake storage and looking at Synapse Link as well. That's where Savine's going to point with some of the integration topics as well. So we're going to try and hit the totality of Synapse today, but I just wanted to frame this up before we move into the next 3 sessions. Now, Synapse in the SQL form factor itself has 2 actual modalities of consumption. There is a serverless form factor today that's a pay-per-query model. It's really geared toward ad hoc exploration over the data lake, and also data transformation that you can then operationalize into pipelines. I'm not going to focus so much on serverless today. I'm going to focus on dedicated. And the reason that we really think about dedicated as being the ideal platform for enterprise data warehouse workloads is that the clusters are persisted with a hierarchical cache It gives you that really highest levels of performance, which is really one of the characteristics that everyone is looking for in any analytics platform, but particularly their enterprise data warehouse. And so today I'm going to focus primarily on the dedicated form factor. Now, in that dedicated form factor, we think of dedicated as having scalability attributes that can suit any class of workload. The elasticity of the cluster means that you can scale down really to what is only a handful of compute cores, or scale actually into thousands of compute cores as well. And that scalability means that you've got the capability to set the mark or set the scale point suitable to a given workload. The storage in and of itself is completely separated from the compute, and it's bottomless for columnar storage in the platform as well. And we have customers, of course, who are running Synapse economically at multiple different scale points, of course, all driven by the characteristics of their workload. Now let's start to get into some of the more technical details of enterprise data warehousing in Synapse, starting with data modeling. Now, Synapse has a very complete storage system, and I'm going to explain each of these 8 features. But the value here for customers when they're deploying and running Synapse in production is that the combination of these 8 storage structures is unique amongst cloud warehouses today. And it enables you to structure your data in such a way that it reduces the I/O all the way down to the storage, which is, as I mentioned, separated from compute. This accrues to significant value for running the clusters in production and potential cost savings. When you've got structures that enable the query processor to identify smaller amounts of data that it needs on a per query basis, that has a knock-on effect of moving less data over the network, so that's faster. You put less data in the cache of the cluster and you process less data. And because the cache and the CPU is co-located in a single cluster, if you have a lower requirement on those resources, you can run smaller clusters to achieve the same output. And that ultimately means you spend less on that cluster. Now, these 8 features that accrue to this are columnar storage, which has pretty much been an industry standard for analytics for quite a while now, and explicit ordering of that columnar store, so that you get an ordering of a column of data within the table, so that when you filter on that table, we can do things at the storage system to isolate or eliminate a lot of the row groups and columns that aren't required for that query. We support replicated and distributed tables, which enables co-location of joins on a single node, even in a distributed system, and that eliminates a lot of data movement. We provide table partitioning, which is traditionally used extensively in data warehouses, particularly for those large fact tables where you've got time series data that probably dates back over multiple years. And partitioning, it gives you another structure to eliminate a lot of the data where you're filtering on that date time, because we can ignore partitions that are not relevant to that query. We support hash distribution, which is also a method for sharding the data across the nodes. Round robin is supported as well, and I'll show you a little bit of the performance characteristics of those platforms and why explicit hash distribution is such a powerful feature. It's a feature that existed in on-premise appliances, and so bringing those workloads into the cloud and leveraging this capability in Synapse is going to make that migration easier and more cost-effective as well, because you're not making a whole lot of decisions around re-architecting data around the platform. We support non-clustered indexes, so that's the ability to order data over other columns for that real needle in a haystack query where you can seek a very precise row, perhaps out of billions of records, without needing to do a full scan of that table. Materialized views create a structure on top of the table where the query optimizer will automatically match to that view. I'm going to show that in the demo as well. And those materialized views also support joins, which means you can actually join tables but aggregate them lower than the cardinality of the join itself. And again, the query optimizer will automatically match that. And the platform as well will maintain transactional consistency of that data as changes are made to the underlying base tables. And so that's really important. You'll never get a result that's out of sync between a table and a view. And the QO will automatically match all or even do partial matching against those materialized views, which means the user doesn't need to worry about a given query hitting a view or a table and understanding how the data platform has been optimized for them. Finally, the result set cache does full text matching against the query coming in. And so if we've seen that query before, and the platform is the smarts to know that the underlying data has not changed, it'll just pull that from the result set cache, and that typically returns in about 200 milliseconds or less. Now, as I said at the top, these 8 features combined are unique amongst cloud warehouses, and they accrue to that value, as I described, of reducing I/O, automatic matching in the query optimizer to leverage those materialized views with joins so that you can join and really eliminate that big join cost and really join once for workloads that may repetitively join those tables. All of it just reduces the CPU requirements and enables you to run these workloads faster. So let's switch over to demo now. I'm going to bring in Management Studio for this one. It's useful to demonstrate the backwards compatibility of Synapse SQL engine with tools that we know our customers have been using, that they've loved for a number of years now. But I'll also show part of this demo in Synapse Studio as well. And so right from the top here, what you can see is I've got a table called Web Sales. This is a table from the TPC DS dataset. I've removed a whole bunch of columns here just for the sake of simplification of the demo. But what I wanted to show you is some of the properties that I just talked about in the previous slide. So first of all, you'll see Web Sales is a distributed table. I've said that I want a distribution, and I'd like to hash that distribution based on the column WS item SK. This is a high cardinality column, and it's going to give us a great shard across multiple distributions in the platform. I'd also like this table to be stored as a clustered columnar index. This is default, by the way. I don't need to explicitly put all data in Synapse as columnar by default. But I've told it I'd also like an ordering on this table based on the customer key. So I'd like to be able to find that customer key really quickly. I'm also going to put partitioning on here. Now, what this means is because the table's partitioned, I'm getting a local ordering of the ship customer key within each partition, as opposed to a global ordering should I not use partitions. But in this case, I'm using partitions, and I'll show you why. And so I've got here 6 partitions, ranging just a calendar year from 98 to 2003. And this means that when I run queries that filter on the sold date, I'm going to be able to eliminate a whole bunch of partitions if I'm looking for a time range within here. And we've done this in SQL Server for many years. But what's new in Synapse is both the distributed and also the explicit ordering of column store indexes. So if I come down here, I can just show you what Web Sales looks like. I'll run a quick query to show you the scale. This came back very quickly. I lifted it out already. It's a fraction over 2.1 billion rows. It's slightly outside the size limits of an integer data type, and so I used count big to return a big int. So we're working with a non-trivial amount of data. And my cluster size in this case is only about 3,000 units. So it's a pretty modest size cluster. And that's by design to demonstrate the performance characteristics of Synapse using what's really a relatively small compute size over, it's not the largest data set, but 2.1 billion is certainly a meaningful size data set. So what I'm going to do is I've got a query here, and we might just shrink the text a little bit to fit it all in. And the first thing I'm going to do is I'm going to go run a query plan on this. And so the first thing you'll see is, as I lift that up right there, there's no shuffles. There is a shuffle, actually. This is actually a very small shuffle. It's doing this shuffle to align the quantity when it does the group by. But I've written this query very intentionally. I've asked for a count distinct of the item key. Remember up here that I'm distributing by the item key. I've also asked it to do a windowing ag where I'm partitioning, and the item key is part of that column set. Now, the query optimizer in Synapse is really smart. What it knows is that this table is hash distributed on item SK. And what that means is that any given instance of a value in the item SK column, could be 1, 2, 3, will always exist in a single shard in my distributed database. So when I run this query, what you're going to see is this is going to come back quick. It's going to come back in about 3 or 4 seconds. And the reason it can come back so performantly is because it's doing all of this work in a fully distributed fashion. It's co-locating all of the push down for this query onto each distinct node in the cluster. And it doesn't need to move the data because I'm hashing on this key. Now, if I introduce partitioning and look at the query performance again, let's go run that query one more time. You'll see that this is going to come in even faster. So now we're down to 1 second. And so this is actually a non-trivial query. The actual meaning of the query is probably unimportant here. It's more the purpose of the demo. But where I'm actually doing something where I'm using windowing aggregates, which are relatively expensive operations. I'm doing count distinct, which is pretty expensive as well. You can see here that when I bring that down, I run the query, we're into actually 1 second to execute that query. And so that's pretty efficient. Now, what I did just to prove the contrast here is add a round robin variant of the table. Now, before I go to that, I'm going to come back to the slides and just explain what happened here. And you'll be able to see exactly what I did. So imagine this is the web sales table. What I have here is partitioning on the sold date that I just showed you. I've got ordering using columnar ordering on the ship column. And then I've got hashing on the items key. So let's talk about the three of those. You'll see here my partitioning means that every record that is of value 1998, or it's actually a full date, but I abbreviated for this slide, is stored in its respective 1998 partition. 1999, 2000, 2001. Super simple. Where I filtered, I think it was on 2000. We've eliminated all of these partitions and only isolated on this set here. The next thing I did was I did a local hash on the item key. And so what I've tried to show here is that the value 1 or 5 or 9 or 1 or 5 or 9 is going to exist in this column, but in this shard. But for a different shard, I'm guaranteed to have different distinct values. What this really represents entirely is a single shard. But what this is showing is as I scale that out, I'll always have different values. And that enables the co-location or distribution on each of these nodes in the cluster without needing to move data. The third was around filtering on ship key. Now, I didn't actually do this. I filtered on the quantity. But where I had an explicit order on the customer key, you can see here that the row groups, which are denoted by these boxes, are ascending 1, 2, and 3. So imagine my query said I want 2000, and actually I want customer SK2 here. We could eliminate all of the data that's represented in here. And remember, I've only got 4 columns here. My table actually had about 25 or 30 columns. I could ignore all of that. And the query processor and storage engine understands exactly how to zero in right on this block of data to resolve my query. And so you can see how we're eliminating that scan of both the table by using columnar. We're only hitting the columns we need. We're only hitting the partitions we need. Within that partition, we're only hitting the row group that we need here. And we're able to do all of the work completely locally on each compute node without needing to shuffle the data. And so this is how this storage system accrues to value for the customer. It's actually really simple to design data models around this. You know, if you've been doing it on appliance form factors, or once you sort of got the basic constructs of this, the benefits are tremendous, and the performance and cost savings it can yield are pretty awesome by using a storage system that we have in Synapse. Now, let me go back to the demo, because I've got a couple of other things that I want to keep showing here. So I'm going to do the same thing with a round robin table. Everything is exactly the same, but it's a round robin distribution. And so I'm going to come back and run exactly the same query. And so let's go do that. And I'm going to leave my query back to 1 and 3 again. I'm going to have to shrink that a little bit to make sure I don't miss any. So we'll go on this. This is going to take a little longer. Now, I warmed this up before the session, so you should assume that we're running cached. And we're doing some data movement here to run the query. So it's still not bad. We're coming back in 8 seconds. But because the table's not leveraging that hash distribution, we'll always run, but it just takes a little longer. And this is the benefit of that hash distributed storage system. It'll just prove that I can run it again. It's only going to run in 7 or 8 seconds, as I showed you. Now, the table is partitioned, however. And so all of these features, these storage features, really intersect with each other. And so should I run that again now and hit one of my partitions, I would expect this to come back quicker. We've isolated the partition. We've reduced the movement. Looks like it's taken a little longer. But maybe I need to warm this one up. But you can see this is gonna finish hopefully relatively soon. The beauty of a live demo. I'm actually going to keep moving here just in the interest of time. Now, if I move down further and isolate, what I'm going to show you is specifically what that local execution does on a compute node. Here's count distinct on my distribution column. So this is not too bad. We came back in, 0 seconds. Now, let me show you if I go run that on a non-distributed column, on the non-hash column. You're going to see this takes a little longer. because we need to shuffle the values to co-locate distinct values onto the node and then do that count distinct. Now, it's not quite a fair test. You'll say, well, the first count distinct was 360,000 rows. This is far more rows, so that's more resource intensive. That's a true statement. But let me show you how I can solve for that with materialized views. So here I created a materialized view earlier. And the really nice thing about materialized views in Synapse is they also let me hash distribute. So now I've got a materialized view that's aggregating pre-aggregating some records from this table, but it's distributed on a different key. So let's come back down, and I'm going to run effectively the same query. I picked a slightly different column here. This is billing customer key. This is shipping customer key. So they're about the same levels of cardinality, which means I'm going to be pretty equal to what I showed before. But I'm going to query web sales. Now, let me show you what the plan looks like for this one. If I come over get, I was querying the web sales, the web sales table, but you can see my output list here is the database.schema.dbo.materialized view shipping data. So this is where the query optimizer has automatically matched a query that was targeted at a table to hit the view because the performance is better. This should take 6 or 7 seconds on the table, but when it hits my materialized view, it comes back instantaneously. And so that's really nice as well. And you can see how these materialized views, again, give you really, in some cases, orders of magnitude performance gains over running it directly against the table. And if I was to add records to the web sales table, well, of course, as I mentioned, guarantee the transactional consistency so the view is updated as well. Let's now switch over to replicate tables. What I did here is I've got dim date or date dim. And I've got 2 versions of this table as well. One is replicate, and one is actually round robin distributed. So they exist already. I don't need to create them, but I have 2 queries here. And so you should imagine replicate tables are commonly used for dimensional tables, date dimensions, customer dimensions, product dimensions, those smaller tables that typically star join into those distributed fact tables. Now, because I've got web sales, which is distributed, and date dim, which is distributed, the optimizer is going to determine that date dim is smaller, and it's going to broadcast that out to the nodes of the cluster to co-locate the join. And you can actually see that. Actually, that's the wrong one. Sorry, that's the round robin one here that I can run. You're going to see that broadcast join right here. So this will be the date dim table right there, and it's done a broadcast that can then co-locate the join. But if we want to eliminate the cost of that movement at all, I can use replicated. And when I show this, you'll see there's no broadcast. And so very simple design patterns. Typically, replicate tables are distributed. Now, if you're joining distributed tables on the joining key, that will also co-locate. I won't show that here in the interest of time, but it was a really quick, pretty technical explanation because I wanted to make sure we got into the code and showed some depth here about how distributed query execution works in Synapse and the power of the feature set within the storage system for really enabling you to build these data models that are going to be highly performant and optimized, reducing the size of your clusters for still producing the exact same level of output and critically supporting those end user requirements. So let's go back to the deck here, and I'm going to pop that up just quickly, and let's keep moving. Now, with respect to data security, what you can see here is it's a very complete story as well. I want to show you some of these very quickly again in the interest of time. The main features that I want to talk about here are at the access control layer. The access control capabilities in Synapse enable you to apply fine-grained security over the data itself, masking, column-level encryption, native row-level security, and column-level security. Sorry, I got those out of order on the data. And what that means is you don't need to go and create secured views in order to apply fine-grained security. Now, this has 2 distinct benefits. The first is you're not constantly building secured views and then keeping them up to date as the underlying schema of the database changes. The second thing, however, is that for the end user, it's super simple because they see a bunch of tables and they query those tables with whatever BI tool they like, and the query optimizer or the query engine will automatically apply the same fine-grained security directly on a per user basis for each query. That's great for user training. You don't need to train different users about which is their view that they need to query, and they get errors if they try to query the wrong view. So it's simple for them to consume. It's simple for IT developers because they're not constantly chasing materialized views. And also by putting this in the database layer, not only do you remove the need for secured views, you remove any need for security at the application layer as well, which is really incredibly impossible, I'd say, to enforce as we move to more democratized models of more people bringing different applications to query over the data. So I want to switch to a basic view of Synapse Studio to show what this looks like now. So we'll start in pool security here. I'm going to move this down a little bit. And I'm going to borrow a few logins from my colleagues at Microsoft. And what you can see here is I'm going to run a query as Mashed. I'm going to run this query. It's going to run this really quickly. And what you're going to see from Mashed's result set when we run this is Mashed's row level security is kicked in. He can only see California, even though he's asking for everything. And what you'll see here is that the first query returned 4,293 rows. I'm going to use the same query text for everything. But you can also see dynamic masking is involved here. So these phone numbers are actually viewable by some people with permission. But in the case of Mashed, they're masked and he can't see them. But we're still on tables. You'll also see that we're applying column level encryption right here. And I'm going to actually come and show you that subsequently in the demo shortly. So now let's go to Anshul. And so Anshul's going to run exactly the same query. So we'll scroll down there and we'll just run that, move it so I can grab the whole query easily. Let's set that up here and run that. And now as we run as Anshul, what you're going to see when the query comes back is she can see the text. There's no masking applied to Anshul. This column is still encrypted. It's a big hash string. We have no idea what the social security number is. That's our most sensitive data. But Anshul's row level security is different as well. Exact same query text. And the simplest way to show that Anshul's returning different data is she only sees 2,800 rows as opposed to the 4,300, I think, that Mashed could see. So let's keep going here and move that down again, the final security demo. Now we actually need to see that secure key. And so now in this case, I need to explicitly open the symmetric key for that column encryption. And I'm going to go run exactly the same query, but I've added a new column here called social security decrypted. And so I'm going to go run this. And when I run this, you'll see I've got a decrypted value here. I needed to explicitly decrypt this in the query. And this actually builds on 3 levels of encryption: storage encryption by default, transparent data encryption for the database itself, and then finally a 3rd level of column encryption combined with the row level security and masking that I showed you. So just a really quick demo about how we can do this fine-grained security in Synapse as well. Now let's keep moving here because I've only got a couple of slides I want to hit to round this out. Workload management is another key capability within Synapse. Workload importance enables you to, again, transparently to the end user, assign priorities on where a query should be positioned in the queue as workloads come in. And then what you can see is workload groups here enable you to define isolation or basically guarantee resources within a single cluster. And again, user workloads will transparently be classified into one of these groups. And so you can guarantee that that global contention within the cluster is solved through groups, make sure everyone gets the right resource they require. But of course, what this min and cap means here is that if my group name, perhaps group A, is set to a minimum of 40, that's my guarantee. But if the other groups are not consuming that resource that's aligned to them, resource group A can automatically scale into that remaining capacity. So you're always getting full bang for your buck on the cluster. But the workload management is going to ensure that it peels back to the 40% if that other workload comes in. Finally, on the lower side, on the bottom here, you can see the clusters are elastic as well. And so the reason that workload isolation is a percentage split, 40 and 100 in that syntax there, is so that as these clusters grow and shrink, that 40-60% will always hold regardless of how the cluster continues to grow. The final thing is around predictive analytics. And so with advanced analytics here, we've implemented the Onyx runtime in the cluster that enables you to bring ML models that you build within Synapse, and Ewan will talk a little bit about that shortly, or actually externally in a whole set of other applications, and operationalize them at scale in the platform. Now I can show you what that looks like as well just quickly. I'm going to flip back over to my demo that I had up and show you what predict looks like here. So in this model, I've got some data. It's a different database, but I'm using an ML model. And what I'm going to go do here is call that model, where model is a model in my table. I'm plugging in some data and I'm saying the runtime is Onyx. The most important thing here is this total amount column. It's not a column in the database. It's going to be calculated at runtime as a prediction based on the inputs of these other columns. And so when I run this, I'm going to run this quickly. What you're going to see here is the total amount column is a prediction. We're calculating this prediction in engine. So in a distributed manner, the Onyx runtime is running in each of the compute nodes. No data is leaving the cluster when I run this. I'm not dependent on an external storage system using REST APIs, which will have a massive impact on my query performance. If I start to move rows from what's a highly performant, vectorized query out to a REST API, there's no additional cost for the scoring service either, of course. And then I think most critically, because you've got this really secure platform set up, and really the compliance boundary of that data is Synapse and perhaps even that cluster, being able to do these predictions in the cluster means you're not externalizing this data out to other entities as well. And so as we start to wrap up here and tie a ribbon around everything we've talked about, Onyx gives you the ability to run these predictions directly in the cluster. I just talked about some of the benefits of doing that. Synapse Studio itself, is a rich development experience. You're going to see a whole lot of other experiences for developing other code as Ewan and Savine walk you through it today. And we also have a very rich ecosystem of other applications that integrate with Synapse. So if you're migrating and bringing other applications, you should be pretty confident that their integration with Synapse is good. And you're going to be able to bring a lot of existing investments as part of that cloud migration. So with that, I will wrap up. Thank everyone for the time. I think we're right on the minute. And I'll perhaps hand over to Ewan, I think.
Yes, thanks. Thank you very much. Yeah, we're not going to have time for questions on this segment, but at aka.ms/learntv, you can ask your questions via text, and we can convey some answers as well. I'm also going to share some links. I've already shared some, but I'm going to share some links about how you can set up some of the things that you just showed with Visual Studio Code as well. Used MS Studio, MS SQL Studio, and the Synapse Studio. There are similar ways you can do things with Visual Studio Code as well, which is pretty cool. I found it sort of buried in the docs, which I shared in links too. So next up, we have Ewan Garden. Ewan is going to talk to us about advanced analytics with Azure Synapse. Adi, did you have anything to add? Sorry, I just steamed through that segment.
I was just curious to learn how they handle data skews, but this is something, we're going to post as a question, and I'm looking forward to hear that response, because I know one of the challenges we have with data are data skews, basically when the data are not distributed in a uniform way, and we still want to make sure we have the fastest queries we can have. So yes, we'll address it later. Thank you.
Okay, thanks. So Ewan, yeah, you're going to be talking about advanced analytics with Azure Synapse, and I'll let you take it there.
Okay, you should be able to see my slides by now. Okay, I'll assume people can see the slides unless Brian yells at me. Well, welcome everybody. It's been quite the high-paced day so far. Hopefully we can keep that up. So I'm going to talk about doing advanced analytics. I'm the program manager for our Spark work, but I've also been responsible for some of our analytics work. And then we've kind of added more people to the team, and that's been taken over now. So that's what I'm going to focus on. So I'm going to focus on Spark and just educating people on Spark a little bit with some slideware. And then we're going to drop to demos, and we'll spend the rest of the time as much as we can just walking through the product, because I think it's a little easier to understand that way. So one of the questions we get asked about Spark is, what should I be using Spark for, and how is this different than open source Spark? Doesn't Microsoft just take open source Spark and ship it inside of Synapse? And the answer is no. So there's a couple of different things here. The first thing is that today we're supporting Spark 2.4. We're working on Spark 3.0. You'll see that at some point in the future. And after talking to lots and lots of customers, we decided to settle on something we call a managed job service form factor. And what that means is our clusters are very fast to start. They're very aggressive about auto-scaling down and also about shutting down, although you can override those settings. So the idea is you submit a job, we start up the cluster, we run the job, then we pause for a period of time that you decide, see if there's any more work that comes in, and if there's not, then we shut down again. This is one of the pieces of feedback we've had because lots of people are really scared about leaving large Spark clusters lying around. So they size them too small, or they just don't give the right number of resources to the members of their teams. And so here you can have a very large cluster, it spins up quickly and spins down again. And right now it's about 2.5 to 3.5 minutes to spin up a cluster of 60 nodes, size medium. For more than that, it goes to about 5 minutes. But 2.5 to 3 minutes is what we're hitting regularly right now. So that's what we mean by a managed job service form factor. Also, as part of that managed service means that you don't really have to worry about a whole bunch of the management infrastructure and upgrades and versioning and making sure the right versions of Spark are on the machine. We do that for you. And because the job service form factor tends to cycle the machines very often, then it means we can pick up patches and fixes, and you don't have to schedule cluster downtime and things like that. And then the last thing is our team actually produces 3 versions of Spark. We produce one that's internal only to Microsoft. We produce the one that we're talking about today, which is Synapse. And we also produce the one that's in HD Insight. Now, the difference between HD Insight and Synapse is pretty dramatic. And that's by design. They're designed to solve different problems for different classes of users. So HD Insight is not a job service form factor. It's designed to bring the cluster up, leave it running around. You can go ahead and do it a job service if you want to, but that's not what it's optimized for. It also gives you much more control. So SSHing into nodes and things like that, which we don't allow on the Synapse side. So that's the basic Spark, and we host it different ways, as I was saying. But then what we do is we go ahead and we add a whole bunch of Microsoft innovation to that open source. And the thing we spent the most time on so far has been performance. And that's because, you know, everybody wants to be faster than the pure open source implementation. And so we work very hard at delivering that capability. And we've made tens of thousands of lines of changes, and we're actually working on a document that's going to document all of that. But as it stands today, the Synapse Spark is twice as fast as open source Spark for a particular set of benchmarks which we use, which are well-published benchmarks in the database industry. And we'll continue to evolve our performance development approaches, because it turns out that if you have a large distributed system that's using cost-based query optimization, and you have a bunch of people kicking around in the org, like the people that, you know, were supporting Charles's demo in terms of some of those crazy queries he likes to run, you know, who spent 25 years doing cost-based optimization on query processors, then they can apply that knowledge, skill back into something like Spark, and not just into SQL Dedicated or SQL Serverless or Azure SQL or some of these engines. So we're able to take some of that learning that's been going on for those last 25 years and apply it into Spark. And you'll see some of that documented, as I was saying. Project Hummingbird is a really interesting way of dealing with ML. So if you take traditional classic ML, it's not super efficient to do batch scoring on it. Charles showed you using the predict function a little bit earlier on. And so what Project Hummingbird does, and the Hummingbird, there's a sample out there, and the bits are in Synapse today, but it's in preview form, is it takes a traditional ML model expressed in Onyx format, and it goes ahead and it turns it into a series of tensors. And for those of you who are not ML nerds, tensors is just a different way of executing ML models. And then it runs much faster, but it'll run even faster with GPUs. And so this allows us to get a performance speed up in the batch scoring. If you're not an ML nerd again, then we do training, which is where the model learns what the characteristics of the data are. We then validate that model with a test training split or a cross-fold validation. And then on the other side, we go ahead and we make use of the model. And that's what Charles is showing you with the predict function. And so it makes that predict function run much faster. But we've also integrated in cognitive services. And so while it's great that you can consume models that are produced, who's going to produce those models for you? If you don't have data scientists in your organization, how do you go ahead and do that? And I'll show you a couple of ways that we can do that as part of the demos. But cognitive services is a series of pre-built models from Microsoft that we train, we manage, we maintain, and we make them available. And so we have integration in with a subset of those services. There's actually quite a lot of them that we think are going to be the most interesting ones. And we'll continue to add more of those over time. And so you're able to go ahead and score on top of your data using those existing cognitive services models as if you had developed them yourself. Hyperspace is a complete indexing implementation that we've built, and we actually open source, so you can deploy Hyperspace on other Spark engines. We make heavy use of it as part of our performance improvements, and it's a technology that will continue evolving. .NET for Apache Spark. We're going to talk a little bit about Spark's extensibility in particular as part of this conversation. And it was great that we have PySpark and we have Scala and we have Spark SQL, but a lot of Microsoft customers they're okay with SQL, but they're not so familiar with PySpark, and they're certainly not familiar with Scala. And so we put C# into the mix. Technically, you can use F# as well, but mostly the usage we see is of C#. And you can write programs in C#, and I have a very simple example I'll show you. You can also write user-defined functions so that anybody else can actually consume your work. And that's a pretty powerful capability to be able to use that language. We have a new caching and shuffle service coming that dramatically improves performance. And then Synapse Link, I think Savine's going to talk about in detail, but Synapse Link appears in multiple places inside of Synapse. And it makes it very seamless for us to query other data sources. Cosmos DB is the one that we've shown for quite some time, and that's the one that allows us to just reach into Cosmos DB and read the data directly into a data frame inside Spark. For those of you who know Spark, a data frame is a tabular data structure that is used very heavily. And from there, we can just process it like it was any other data frame, as if we'd loaded it from disk, or as if we had done anything else with it in terms of how we'd constructed the data frame. You can do it in code, you can read from disk, you can read from HTTPS. Then the last thing we do is we listen to customers a lot. We have the advantage of having had HD Insight in market for a number of years. We have the internal customers as well. And so we're able to spend a lot of time with internal and external customers. And what are the things that are really important to you? So we have an improved notebook experience that I'm going to be showing to you. You can switch it on. It's not on by default for external customers. We have operationalization for notebooks that we're continuing to evolve. And what that means is you can take a notebook and in 2 or 3 clicks, you can turn it into a notebook which gets executed in a Synapse pipeline, and therefore it can be scheduled, it can be triggered. We have a Scala experience inside IntelliJ. Lots of people don't know this. More than 80% of the Scala code that's written in the world is written inside of IntelliJ, and it's a great experience. And so we've written a plugin for IntelliJ that makes it very easy to write Scala programs in IntelliJ, test them, and then go ahead and deploy them up to Synapse. Scoring and Training Wizard, I'm going to show you both of those, so we won't talk about those in any depth. Delta Lake. Delta Lake's a very popular transactional Parquet format that was introduced by Databricks, and they open sourced it, and we include support for the open source version. Extremely popular with many customers. MS Spark Utils is a series of utilities to just make things simpler to do when it comes to executing one notebook from another notebook, to getting credentials. There's a variety of different capabilities in MS Spark Utils, and we'll continue to add more there. And it's just to simplify the API surface area. And then the last thing is, and Charles briefly touched on this, is metadata integration with Synapse SQL. And what that means is that when we create tables in Spark, for example, they can be seen in serverless SQL today, and they'll be seen in dedicated in the future. And when you create tables in dedicated SQL in the future, like Charles was doing, then you'll be able to see them and query them inside of Spark. So one of the goals and the principles that we have is of shared metadata inside of Synapse, so that every compute engine can make use of the data produced by every other compute engine without having to dump and reload. And this is one of the things that Charles touched on. Okay, enough with the slides. Let's go ahead and we'll take a look at the product. So I'm going to fly through a bunch of different scripts and notebooks. I'm not going to run them live because we don't have a ton of time today. So this first one here is just going to set up some data that we're going to use in other places. And so here we're taking the New York Taxi yellow cab data. If you're not familiar with this, it's a data set which tracks 1.5 billion cab rides in New York. And you get all sorts of interesting information like pickup location and how much the tip was and whether there was a tip and how much people paid. So in this case, we can read it live over the internet, but it's not super fast. So I have a cached version that I run locally inside of a storage account, and it's 150,000 rows, which means things tend to run a little faster. And here you can see the output from that. I have the choice of a table view, or I can go ahead in here and I can look at a chart view. Not the smartest default in the charts. We're going to do some work there. I can also open up Spark History Server and take a look at what was going on when this was being run, this application. And if you've never seen Spark History Server before, it's quite intimidating. We'll come back to it once it's loaded. And I can take a look at metadata. If you're not a Spark person, then all of this is kind of going over your head. If you are a Spark person, you're sat there going, well, yeah, Ewan, nothing new and exciting there. Okay, so let's take a look at the first thing that starts to show the power of Spark here. So the language we're using is up here. It is PySpark, which is a special Python variant that runs inside of Spark. But down here, you'll see we have %% Spark. It's called a magic, and it allows us to run Scala code. And so what we're going to do here is we're going to create a database that, if it doesn't exist, called New York Taxicab. And then we're going to go ahead and read this data set here from Small SQL Dedicated, which is the engine that Charles was just talking about. And then we're going to write it back out again as a table. And so here you see some of that interop coming into play. We're doing it with Scala because this SQL Analytics driver is only available in Scala today, but we'll look at adding other capabilities later. Here you can see information about what was actually executed. In this case, we used 40 cores. It executes nice and fast. And now we can start pulling data back out again, just to verify that what we did actually worked. And so this is a copy of the data that was further up. Now we can start doing some manipulation of the data and ready for analysis. And you can use any of the compute engines to do analysis. So you can use serverless SQL. It's great for doing ad hoc analysis. And then you can use dedicated SQL for doing more structured analysis, some of the stuff that Charles was showing. And then you can use Spark to do either, although it tends to work a little better with the unstructured analysis or the ad hoc analysis, but it can work just as fine with tables as it does with any of the other structures. And so here you see that we're just going to pull the data out, and we're just going to do the sort of thing that I would do with a relational database engine. I'm going to compute some aggregates in here. I'm going to add a filter in here to filter out only valid data. So, hey, we only care about trips which are longer than 0 and the passenger count where it's more than 0, because otherwise it doesn't actually make sense. And we've already saved this table away, so we've created this new table called passenger count stats. Okay, and this is what passenger count stats looks like. Here we can see what's the, for passenger count of 1, what's the sum of the distances, and what was the average trip distance. And there's a couple of weird things in there in the data that we'll have to take a look at and see if they need cleaned up. And then at the very end, we're going to go ahead, I'm going to go ahead and write that again using Scala, and we're going to go ahead and write it into our SQL Analytics store, so that we now have inside of the SQL dedicated store, we now have copies of this data that we processed. The goal in the long run is you won't have to copy the data, that you'll just have a pointer to it. All right, so let's go ahead here and we'll take a look at the dedicated. So now we're going to go ahead and make use of that. Except there's something wrong with the metadata. We'll try running that again. Let's just go see. So here we're just going to compute on top of that data. So here we can see trip distance miles. Remember, this is on top of the raw trip count. So this is trip, not passenger count, which was the summary data we just posted. So I'm going to compute the trip, sum, and average, and I'm going to go ahead and I'm going to filter by the same things that I filtered by earlier on, and I can keep going. And so now what I've done is I've done the same thing twice, but I used Spark to do it one time, and I've used our dedicated SQL engine to do it the other time. And if we go in here, oh, there we go. It's the window I want. Here I can actually go ahead and select the data. Here I can go after the raw data. So this is the power of SQL dedicated, but I can also do cool things like this. So if I bring out the storage browser, you'll see here we have 3 databases. And let's go ahead and we'll pick the New York Taxi database, which has passenger count stats. And we'll go ahead and say we want a new SQL script here. And you'll see it's connecting to built-in. Built-in is the serverless engine that we have, and it's going to do select top 100. And remember, this is passenger count stats, so this is actually the aggregated view. And so now what we're doing is this is on demand. So it's going to spin up some query resources. There's no dedicated cluster lying around, and it's going to go ahead and pull it out. So what I'm trying to show you across these 3 engines is we can have data in the lake, and it can be in files or it can be in tables in this particular case, and we can pretty much use any of the engines to analytics that we want to. And we can do different types of analytics in different places. So let's go ahead and take a look very quickly. This is a very famous example. This is the word count example that it does inside of Hadoop, except if you take a look at the language up here at the top, you'll see it's C#. Now, this is a very small subset, so you can see that the words, .NET appears 3 times, Apache appears 2 times in this very simple quote, but it gives you the idea. I also get charting. If I want to go off and compute a histogram and display that, I can go ahead and do that. And so C# is very much a first-class language inside of this compute engines that we have here. All right, let's hide the storage window away. Now, things that are very powerful about Spark is, first of all, there's a lot of extensibility, as you can see here. So there's lots of functions that and capabilities we're adding. This is the one I want to call out here. And I'm going to scroll through this. If you're familiar with the yellow cab data, this is just simply we're going to downsample the data. Then we'll do a little exploratory data analysis. So we're going to do some charts, which take a look at some of the usage patterns inside of the data set. So here we can see the tip distribution. And so the tip amount is 0 for a lot of people. That's kind of mean. And there's a little bit of a nice little area here. So $2.50 for 250 people. So we can see the distribution then of the tip amount. Here we can see passenger count and see what their amount of tip is in relation to passenger count. And then finally, we can take a look at tip amount by fare amount. And you can see here, there's our 0 data down at the bottom. A lot of people, no matter how far they're going, give 0. And then there's a somewhat interesting pattern here. There's a couple of them which show that as the distance increases, then people are actually willing to pay more. So that's good. Not everybody's being super cheap. So we'll keep scrolling down here. There's a bunch of featurization, which is just computing columns and dropping things. Then we do some nerdy ML stuff where we encode things. Then we split the data and we say, hey, we're going to do some training and we're going to do some testing. And we're going to go ahead and do a logistic regression in this case. We're going to use area under the ROC curve as our way of assessing success. And I'm going to take a look at this final chart. And that's very much what you want to see between true positive rate and false positive rate. You want to see it go up very steeply and then get to the top and stay that way. So I just scrolled through an example very quickly. This is in our documentation and it's in our samples website. So you can go ahead and take a look at it there. And this is all done inside of Spark, with the exception of converting the data into format that matplotlib can render, which means I have to convert it into Pandas. So this is PySpark this is done using, not done using Python in this particular case. And so let's go ahead and we'll switch to this one. Now, what starts to make ML really powerful in these sorts of environments, and this is another example uses New York taxi cab yellow data, but I'm going to scroll down through this. This is a slightly simpler version. This one actually uses pandas, so it doesn't work with such big data sets, but you get the idea. And here, what we're doing is we're going to use Azure Machine Learning. One of the hard things about doing ML analytics is you might need thousands of experiments to get to the finish line. And so from that perspective, how do you know which one was the best one? Which parameters did you have? And Azure Machine Learning provides a great capability to allow you to do that. So that's what we're doing here is we're setting up some of the metadata that's required to use Azure Machine Learning here. And here we're actually going to go ahead and not just log the information, but we're going to use something called AutoML. So even for experienced ML customers, trying to work out which algorithm to use, which featurization strategy to use, where to start your hyperparameter suites can be a little tough. And if you don't have a ton of experience, if you're a brand new data scientist, then it can be intimidating and it's hard to get right. And so AutoML uses a whole variety of different techniques to take a look at data and try different strategies. It tries different algorithms, it tries different featurizations, and it also tries different parameter boundaries. And then it pops out the other end and it says, hey, here's the one I think is best based on the criteria you gave me. And so that's what we're setting up here is we're just setting up a regression AutoML run. And then we'll keep going down here. Now we create an experiment. And we can see we're going to take a look for the best run. Now I'll just scroll down the bottom here. And then we're going to go ahead and publish that and take a look at the results. So what we've done here is we did an auto, and it takes a little while to run. What we did was we used automated ML, so AutoML, to take a look at that exact same data set that you saw all that code that I wrote by hand. And it's going to pick the best answer, and actually picks a better answer than I do in terms of featurization, parameterization, and also the algorithms that it uses. But you have this big corpus of data, and it's in Azure Machine Learning. It's not something unique to Synapse. So if your data scientists want to go inspect the work that was done by the more junior data scientists in the org, or by the kind of the no-code, low-code data scientists, then they can go ahead and do that, and they can see all the details they want to be able to see, and they can approve models being published. All right, let's fly around a couple of other things before we head out and take some questions, perhaps. So if we go, that's not what I meant to do at all. This is what I meant to go. So if we go in here, back to the databases, you'll see here that we have a dedicated SQL, and we should have a table in here. Go back metadata. Okay, there's passenger count stats, but there's also trip. So remember, trip was the thing that we were actually doing all the ML on. So what are some of the options that we have here? Well, this is kind of cool. I have this machine learning option. Or I did have this machine learning option. Where did it go? Okay, and I can go ahead and enrich with an existing model. So that's essentially what Charles was showing you, except he did it in code. I can go ahead and use a wizard to do it. And it's going to go ahead and enumerate my Azure Machine Learning workspace. There's nothing in there right now. I can choose a different workspace, but that's the only one that I found in right now. I'm not going to go through the wizard steps here, but what it does at the end of the day is it generates the capability to do the predict function that Charles was showing you. Let's switch to a different table. So we'll go ahead and we'll switch to trip, but we'll do it over here. Machine learning. Now we have enrich with an existing model, or we have with new models. So let's go ahead and do enrich with existing model. Again, there's no models in that demo workspace that I'm using, but we do have cognitive services. And so if I want to do anomaly detection or text analytics, I can go ahead and just use one of these models. And we'll zip through this. Let's see. No, I need to select an account here, so it won't work. But we can choose one of these two cognitive services, or if we had our own models, they would exist here as well. And as I said, we'll continue to add more to the cognitive services list. And I can go ahead and apply that and do batch scoring on top of my trip table. What's even more interesting is think about all this code, even the AutoML stuff that I showed you. It's a lot. And so what we have here is we have a wizard. And here's the workspace I'm going to use. Here's my experiment name. Here's what I want you to call the model. We'll go ahead and we'll pick the column that we want to predict. Let's say we want to pick the tip, let's do tip amount. So we'll go ahead and predict the tip amount. Which Spark cluster do you want to use? We'll use this one that we've got here. And so we'll do a regression model. How do you want to validate your model? How long do you want it to take? What's the max number of iterations? And do you want it to be ONNX compatible? If you make it ONNX compatible, then it can be consumed in the predict function that Charles showed you. So I can either kick the run off, or I can simply look at it inside of a notebook. And so here, this code will look very familiar. It's very much like the code that you just saw. There's the AutoML config. There's display HTML to actually render a nice, pretty picture. And there we're going to go ahead and register the winning model inside the EML repository. So we've looked at a series of different capabilities that we have here in the product to do analytics on data, whether it's BI analytics with group bys and joins and things like that, or whether it's more sophisticated in terms of machine learning. We've looked at how we can consume those. The nice thing about both of our SQL engines is they are just SQL engines. And so anything that understands a SQL endpoint can go ahead and connect to them, and you can consume them. That means tools like Power BI and the like. And in fact, if we go in over here, I've actually got a Power BI model over the top of that summary data. So if we take this passenger data and, oh, that's not playing nice. So if we take the passenger data and we'll add a line chart over here. And so we'll add passenger data as an axis, and then we'll add the other two as values. Okay, so now inside of Synapse, I'm also able to build and validate some reports. All right, at that point in time, I'm going to pause. We have 4 minutes, so I'm going to beat Charles and actually have time for questions. So let's go ahead and see if there are any questions.
Hey, great stuff. Adi, did you have any questions?
Yes. Thanks, Ewan. It was great. Questions about the different projects that you're working on. So Project Vegas, is that an open source or something that is proprietary for Synapse?
Currently, it is proprietary for Synapse. Like a bunch of the technologies that we build, like the Spark .NET implementation inside of Spark, the hyperspace indexes, we'll have to decide what we want to do with that. There's also all of the performance enhancements we made to open source Spark to get it to twice the speed of the current 2.4 open source. We'll have to think about those ones and which ones make it back. We do already have members of the team contributing PRs into the Spark code base, but we'd like to get a few more.
Cool. And regarding hyperspaces, so you mentioned it's an open source. So if I'm a community member who would like to contribute, but I'm not a Microsoft employee, is there a specific process I need to go through?
Go to GitHub, take a look at the code, look at the guidelines for committing to the project. and then go ahead and submit your first PR. Currently, it's managed under the Microsoft open source umbrella. We're going to either go to Linux Foundation or Apache Foundation at some point, but just to allow us to get the thing bootstrapped, it was easier to do it under the Microsoft open source umbrella.
Cool. All right, Brian.
Yeah, a couple of things I wanted to add, a few things that Ewan covered. Just want to show them on my screen here. We've got any questions you want to ask, by the way, Ewan, if you go to aka.ms/learntv, you'll see our interactive chat there, and you can ask Ewan and others any questions that you might have, and we'll be monitoring that during the rest of the sessions, which is about 30 minutes. But here on my screen right now, if you could show my screen, I'll bring that up, hopefully. Thank you. Yes, all of the links that I'm going to be showing here today are at aka.ms/thelaunchspace. But I wanted to highlight that we have a lot of Synapse documentation. There's kind of 3 levels for it. So there's some Synapse Analytics. There's a tutorial section as well. Ewan, I noticed a lot of the stuff you're talking about is actually here using Spark and Hive tools and PySpark and a few other things. There is a great tutorial that I found kind of buried down underneath how-to guides, use notebooks and IDEs, and it's connect to Spark pools with VS Code. And it's got a cool way of actually interacting with a lot of the things you showed in your demo just from one pane of glass, if you will, one IDE that we have there. And you install a couple of extensions and then basically run through the setup. And it's pretty cool. The tutorials are awesome. Aside from tutorials, the next level we have for that is the Microsoft Learn TV. And once again, the links are at aka.ms/LearnTV and also at aka.ms/thelaunchspace. But the difference between Microsoft Learn and the regular tutorials is it's interactive. And if you sign up, you actually can get some points and things for going through this. And it is directly related to certifications at Microsoft as well. So a little extra beyond the regular documentation and tutorials. I urge everyone to check it out. Next up, we have, thank you, Ewan, that was great. Next up, we have Saveen Reddy, and Saveen's gonna talk to us about integrating data with Azure Synapse. And I'll let Saveen take. Saveen, you're actually on mute. Hey, Saveen. There.
Sorry. I always get confused. Hello, everyone. Thank you for the time. I always look forward to these opportunities to get a chance to talk about Synapse. So today, in the last session, I'm going to focus on, of course, integrating data with Azure Synapse, which really, to be honest, is what Azure Synapse is really about. So, the theme of what I'm going to talk about is really no code. Now, in the middle of my demos, you're going to see me show a lot of code. But at the end of all of this, what I'm trying to really get across is that the amount of, you can go to a place where you're doing much less code and you're having to avoid writing code at all if you can. And Azure Synapse enables this. And actually it enables this through 2 ways, which I'll demonstrate. One is our new Synapse Link feature, which is all about doing analytics on operational data. It removes a large amount of code and time and energy and frustration in building ETL pipelines. So that's the amount of code that will disappear. The second is, in the process of transforming your data, you typically write code for that. Of course, Azure Synapse shares the same data flow engine that is in Azure Data Factory. So if you're not inclined to write code for that, you can simply use a graphically oriented graph-based data flow system, and I'll demonstrate that as well. Now, some of you may have heard about Synapse Link, but I think it is still very new for a lot of you. So I want to step back and help you see the context of why it's there and what it's really about. So it is fundamentally about analytics on your operational data. And, Synapse integrates with so many sort of data sources. I want to place Synapse Link in the right place in your mind. So again, I said Synapse is all about integrations. And in fact, when you have a Synapse workspace, there are different styles in which Synapse integrates with other services. A classic one is what we call just linked services. And this really is reflective of the, I think it's 95 now plus connectors that let you orchestrate activities and other services or move data between them to and from Synapse, from other cloud services, as well as even on premises. So that's linked services. It's the the bread and butter of what we do in Synapse in terms of data integration. The second kind of integration we have is, I don't have a great word for this, but we call it enhanced integrations. And that is, there are special services for which you might see an even deeper, usually an experience-based integration inside Synapse. And the three that stand out here, of course, Data Lake Storage Gen 2, Azure ML, and Power BI. If you've used Synapse Studio, you'll notice Synapse Studio is even more optimized to make it seamless to move between those three services. Okay, and finally now there's another kind of integration, and this is Synapse Link. This is letting you do analytics on operational data. Now, today that's focused on Azure Cosmos DB and letting you use Synapse SQL or Apache Spark and Synapse to access data in Cosmos DB. In the future, other operational data stores will be supported, but we start off with Cosmos DB. Now let's take a look at what the world is like in Cosmos DB without Synapse Link. And this diagram is, I'm talking about Cosmos DB, but really it's true for any operational data store you have. Your first option for doing analytics workloads on top of an operational database is you do both operational queries and analytic queries on that same database. For many systems, especially at smaller scale, this works fine. The negative with such a system is this. Number one, the operational database is really meant to do a certain kind of things, fast inserts and updates. The sales records have to come in from the point of sales machine like very fast. So it's geared for that kind of row-based sort of modifications and reading. And that's where its life is. And if your scale is not too big, you can start doing aggregated queries where you're starting to look at, for example, sales trends across weeks or months or quarters. Eventually, people will hit that point where the power required to support the analytical queries is now impinging upon those operational queries, those updates of rows, et cetera. So at this point, we've got a real struggle, right? People need to keep the operational database going because that runs the business, but then the other half of the business needs to do all this analysis. What do they do? Well, the next option then is you split the workloads. So of course, the operational database, you sort of dedicate that to operational queries and inserts and updates. And then you create an ETL pipeline. You move data periodically over to an analytics database, maybe an OLAP cube, for example. And then all your analytics queries are there. Now, this approach works. Now, the price you pay is, of course, there's a latency for moving data from left to right. That's one thing. And that's always the case. But you got the benefit of these queries. Now, analytics are not impacting your normal bread and butter operational inserts, updates, et cetera. The other thing that's hidden in the complexity of building that arrow, that blue arrow on the right. So Synapse Link is all about making that arrow simple or just removing it. Today, you could think of that arrow as really, it's a barrier because you have to build and maintain something that periodically copies data, has to deal with schema changes, has to deal with updates to the data. And you have to monitor it, and you have to figure out how to partition the data and what data format you're going to use and where you're going to store that data and what kind of format, et cetera. That's a lot of thinking and planning, and it's fragile. And that is a cause of a lot of frustration for people. So Synapse Link is trying to simplify the creation of that ETL pipeline. And that's the first time, now we'll get in that no-code theme. Essentially, Synapse Link takes that away. In fact, you could think of Synapse Link as simply enabling analytics on top of your operational data. So it's basically real-time. Changes that happen in the operational system very quickly manifest in the analytics system. There's no ETL required. You don't have to write a lot of logic or code to deal with, what do you do as new data comes in? What do you do when schema change, et cetera? And finally, because of course it's separated, there's no impact on your operational system. So that's fantastic. right? You sort of got the best of both worlds. You didn't have to write any code, and you got your analysis, and you didn't hurt your operational database. So that's fantastic. Now, a little bit of peek under the covers and what's actually going on here. So, of course, this brings it back to Cosmos DB and Cosmos DB containers. What's really happening is, you have to enable analytics on your Cosmos DB containers. So what that means is when you've enabled Synapse Link, you've turned on the analytical store, a container will typically have a transactional store. And this is, as I sort of mentioned before, kind of optimized for rows, right? Reads and writes and updates. Now, what will happen is when you enable the analytics store, there's a synchronization process from the transactional store to the analytics store. That's all under the covers for you, right? And once that analytics store is there, invisibly, you don't have to manage it. You just have to turn it on. And I think the only button, so the only sort of knob you have to control is a timeout for something there. That's it. You simply turn on the analytical store. Suddenly, that enables Synapse to do high performance analytics without impacting your transactional workload. So that is what Synapse Link is, right? And if you turn this on, suddenly Synapse has access to it. And that's going to be the basis of my demo. Now, notice the diagram says that Synapse Link gives you two ways to consume that data in Synapse. The first is serverless Spark pools and then serverless SQL. So the minute you connect one of these containers, both are available for you to use. And I'm going to demonstrate that for you with some very simple demos. Okay, so we'll do both Apache Spark for Synapse as well as serverless SQL pools for Cosmos DB. Let's go and launch my demo workspace. So let me expand this out to be a full screen. And you should be able to see everything. There we go. Okay, so this is my workspace. And this is the home blade, or sorry, hub, as we say. So we're going to just do a little bit of exploration before I start getting into like writing queries, okay? The first is, I said you had to link a Cosmos DB container. How do you do that? Well, we'll go to the data hub. I click, and you can see in the data hub, I have workspace data, and it says linked here. Now, workspace data, I'm going to collapse it, are all the databases that the Synapse workspace itself manages. Things that are not managed by Synapse are considered linked data sets or data sources. That's why I'll go here. Now you can see, and I'll collapse these headers, that this workspace has links to many kinds of services. And you can see Cosmos DB is there. And if I expand this, you can even see these three containers: store demographics, products, and retail sales. And this is where we're going to play. Now, how did I even get Cosmos DB there? And it's very simple. I click on here, and I'll say connect to external data set. And then I'll pick, Cosmos DB here, continue. And, I'll do the normal things I do to connecting any link services to my Synapse workspace. I'll have to give it the account name, a database name, etc. Okay, so I won't do that right now because I've already done it. Now, once I've done that, and so it linked this one called Retail Sales Demo DB, okay? And these are the three containers inside. Now, it may be a little hard to see, but you can see the icons here have three little column chart there. And that indicates that container is enabled with the analytics store. So that means they're enabled for this fast query with Synapse. Now, what we're going to do is we're just going to show you how easy it is to start playing with this. Remember, all I did was link, and then these now appear as linked data sets in my data hub. So let's take a simple one. We'll do products. And I'm going to right click, and you can see it says new SQL script and new notebook. I'll go ahead and just hover over new notebook and let you see what's possible. We won't explore everything. Load the data frame, write data frame to container, so you can write back. Create a Spark table. There's even streaming from load a streaming data frame. We're going to stick really to load the data frame because that's the simplest and fastest way to show you what's going on here. So I'll click load the data frame. And let me hide a little bit of this UI so you can see a little more clearly what the code is doing, right? So first of all, it's identifying the kind of, it says spark.read. It's identifying what's happening here. So this is Cosmos DB. It's doing analytical queries, OLAP. It's specifying the link service. Remember I told you I did plus and I added the link service? It's referring to the name of that link service. Okay, and that'll become very important in just a second. The second is saying which container, which is of course products. Okay, and then it reads that in the data frame and does a display. I won't run this because I have a separate notebook that's already ready with some extra sample code. But there is one thing to pay attention to here, which is notice nowhere in here does it specify a key, like what authentication is being used. So that's the great thing about our link service integration is the key is stored in that link service configuration. You don't have to see it in your code, which is of course not a good practice. It's much better to do what we're doing here, and we reference the data without putting it in the actual source code. This is great, simple, and it's very secure. Now I'm not going to run it because I already have a notebook ready for this. So let's go ahead and just do it in separate notebooks. I'll close this and I'll load up my other notebook. Okay. Now I have run this already, so I have a Spark a session going already, but I'll run the cells individually so you understand what's going on. So in this case, I have the very same query, except it's going against the retail sales container, and I pick a few columns to display. I'll go ahead and just run this cell. Let me comment out this one line. So I'm displaying product code, quantity, price, and store ID. These again are the actual sales transactions. Let's just run that. And there you go. Nothing surprising here. You can see I have a product code and it's Surface Pro 7, Surface Go, a quantity, a price, and a store ID, right? Now there's another container there, right? I also have information about the products. For example, nowhere in here do I have the wholesale price. That's actually in the products container. So I'll do a slightly more modified query or cell, same pulling of the retail sales. Now I'll pull another data frame, which is products. Now, because I'm not such a good writer of PySpark code, I tend to use Spark SQL within my PySpark cells. What I'm going to do is create two temporary views, one called TV retail sales and TV products, because I'm going to refer to those later on in other cells. And I'm just going to create those two temporary views. And you can see here's the data for both, just the top 5 rows in both. So now I have two temporary views available for my future SQL queries, my Spark SQL queries. And now, of course, just to prove it all works, let me run this cell. There, it ran. So now the temporary views are created. Now let's just do a quick check to make sure I'm actually able to query those temporary views. I'll query the retail sales table. Yep, all works. And now what I'm going to do is I'm going to do a join. So what I want to do is I want to find out the wholesale price for every row, not just the retail price that they were sold for. So wholesale cost, you can see this join comes from the products temporary view. And I just want to essentially add this column with a join. So I'll go ahead and run that. Okay. So now you can see now I have all the fields plus wholesale costs. Great. So now we're actually joining that table from that comes from Cosmos DB. Now I've already created a database using this create database statement and it creates a database called febdemo. And then I am going to just show you, I'm going to write this data, which is this the thing I did a join on. I'll write it to a febdemo.retail sales table. So I'll write that. So now we've gone from Cosmos DB to Spark as a data frame. Now I'm saving it as a Spark table. Okay, because I've done my, the cooking I need to do with Spark. Fantastic. It's done. To prove that it's done, let's go ahead and go back to the data hub. And I will go ahead and refresh my databases to pull in the updated table. And you can see, here's a Spark database called febdemo. And it should be one table in it called retail sales. And guess what? I could run a notebook on it, of course, since it's a Spark table, but I'll actually query it with just serverless SQL. And so you can see now, you can cook your data with Spark that came from Cosmos DB and query it with serverless SQL, and there you go. And just to prove, just make this a little more real, I'll just replace this query with a quick aggregation. I just want to see the number of sales that occurred by product code, right? So let's just run that query. And there you go. So what had happened here in this entire sort of demo we did is that, again, we just connected to Cosmos DB. We didn't have to worry about the data format. It was stored as some Parquet files somewhere. I didn't have to know about that. I didn't have to know where that data lake store is. I just have to right click on the data and start querying it with Spark, and it just works. So that's, even though I showed you code about the querying, there was no code to do the ETL process. And that's the key benefit of Synapse Link. And as I mentioned, this is just the beginning. Remember, in the future, we'll get more and more operational data stores connected into Synapse via the Synapse Link feature set. Okay, so this was Cosmos DB with Spark. And at the end, I said, hey, let's query with serverless SQL. Well, a lot of you don't want to do that. A lot of you don't want to live in the world where there's Spark and SQL. You're SQL people, and you just want to query with SQL. Don't worry, that works too. So let's close this script here. And just as we did before, I'm going to find the link data set, and I'm going to go back to retail sales. And this time, I'm going to do a new SQL script. Okay, and I'll just run this. Before I run it, let me show you what's in it. So what it's going to do, it's going to, now this is in preview. So it's connecting to the same Cosmos DB account, the same database. It's picking the retail sales table, but it needs the key. Now this is where we haven't fully integrated it with our link service. Now in the future, what should happen here is it'll just say the names of the things at once, and you won't be seeing the key in the code. So I'm going to paste the key in the code in a separate sample, and this is the thing that'll get better over time. But you'll get the idea of what's going on. So I'm going to close this, and I already have a SQL script generated. Let's go here. And let me scroll up. And just so everyone's on the same page, there's a lot of SQL statements here. I'm going to select the text I'm going to run and then hit run. So this is the same queries you saw before, except I have, of course, the key is there, right? So I'll select this and run it, and this is going to go against the products table. Yep, and then this will go against the retail sales table. Same thing I did with the Spark demo. I'm just querying the tables, again, from Cosmos DB. Now I want to do my join, okay? Now to make this a little more obvious what's happening in the join, I've decided to use CTEs, common table expressions. So I have one that returns the products from Cosmos DB. I have one that returns the retail sales rows from Cosmos DB. And then what I'm going to do is I'm going to just join them together. So I do a select top 100. Here are all the columns I want. I select star from retail sales, inner join, select star from the products, and then I join on the product code key. And let me select this text and I'll run it. Let me get a little. Oops. There we go. Run. And there you go. As this runs, what's happening again, it's pulling for Cosmos DB, it's doing the join. I could have done my aggregation. The key thing is I didn't have to go to Spark. I can go directly with serverless SQL. Okay, so that is really the magic of Synapse Link. You can use Spark or SQL, and you didn't have to write any code to build the ETL pipeline. Okay, so now let's get on to the next part of what's in our no-code world in Synapse. And that is data flow. So data flow is about code-free data transformations, and these are used in Synapse pipelines. And here's a picture of one. We'll work through the UI briefly. Key thing is you live in this graph. You don't have to write code. And the cool thing about writing this graph is very simple. It's a very guided experience. And what's happening underneath it, it's actually building a Spark program. So it's actually using Apache Spark and Synapse to run this code. You don't know it, but that's what's actually happening. And of course, it has all this great monitoring, et cetera, for all the pipelines and these data flow activities. So it's a really powerful system if you don't want to write any code, because the code can get ugly if you're talking about PySpark or even SQL. This is a much easier world for a lot of people. So there's a list of some of the capabilities. I won't go too much into them. Let's just start with the demo again. And let's see. Okay, so I'm going to show you a basic demo, which is, it won't take too long. It won't take a few minutes to show you the spirit of it. It's how do I get a new data flow? So what I would, to understand data flows, you must understand first that you need something called an integration data set. And in this workspace, I've linked a lot of them. And one of them is to that Cosmos database, Cosmos DB database to retail sales and the other containers. So all those links are in here. And some of these are to different things. Some of them are to Cosmos DB, like this one, Cosmos DB SQL API collection 1. So now that that's there, I can use it in a data flow. So let's show you how that would roughly work. I'll go to my develop tab. I'll create a new data flow. And I need to pick that integration data set. So I click add source, and then I'll pick the data set and I'll find it, this one, right? And then now once I pick it, I can do joins, I can do selects, and I'm just going to add some of these to help you understand. I can do filtering or sorting, etc. So I just graphically build these things up, and in each one, I will, for example, I will select the columns that I want. So maybe here, this is another table. I'll pick the store ID, and this is some demographic data. So I'll pick income, etc. All graphically driven. Okay, so that's how to do it. And just to show you the real data flow, because I'm just playing around here. Here's a pre-built one. Oops, gonna zoom. Let me reopen that. Looks like the zoom went a bit nuts. It should be this one, yeah. There we go. So this is a pre-built one in the workspace, which again, pulls from the very same data source from Cosmos DB, creates some new columns, you can see here, right? It maps the income column to a float, does some type conversion. It selects some other columns, and then, it saves it to a data lake, and that's it. So now we've gotten to see two ways, really, you can think about doing no code in Synapse. One is using Synapse Link, because it removed all the code you needed to write to create an ETL pipeline. The second was data flows. So if you weren't keen on using PySpark or Spark SQL or T-SQL, you could have just interactively created a graph that would, underneath the covers, write a Spark program for you. Very easy. So those are the two no-code options that really simplify how you can integrate data with Synapse. Okay, I think that's it for me. So I can.
Wonderful, beautiful. Thank you for that. Hey, I just wanted to show a couple of things as well. Adi, do you have any questions while I'm bringing this up?
I just want to say it's exciting to see how we can combine both worlds into one studio.
Yeah, that's great. I did want to show a couple things. Bear with me a moment. There we go. So some of the things that Savina's talking about, if you go into our docs, you can actually see several parts of this. Whoops, there we go. In Azure Synapse Analytics, there are some getting started. And if you go to the quick start here, connect to Azure Synapse link for Azure Cosmos DB, it actually highlights a lot of this, and you can follow along with what Savine did as well. There are Microsoft Learn modules for this too. And all of this is going to be displayed at ACA-MS, the Launch Space, Synapse and Purview. And there's the QR code if you want to go there. Or if you just go to aka.ms/the launch space and then click on the Synapse and Purview link, you'll find all of these as well. And I just want to say thanks to everyone for joining today. It was wonderful. I think this is really, really good info. It was a nice progression of topics, and thank you so much for Adi for co-hosting as well. It was great to have you here and have your expertise on hand as well. So do you have anything to conclude with?
Well, I think it was definitely an exciting event today, and the lineup was fantastic. I learned a lot. I hope the audience learned a lot. And again, if you have questions, please feel free to reach out and ask. I believe it's the best way to learn. Yeah,
aka.ms/learntv for the next few minutes. We'll be on there, and you can post your questions there. But otherwise, yeah, join us. Check out the launch space. aka.ms/the launch space, and that's where you'll find all the links and info for today. And I'll also be posting the slides and any videos and anything I'll be embedding there as well. So thanks to everyone. Thanks, Saveen. Thanks, Adi. Thanks to all the other speakers. Great show, and wonderful to have everyone here. Thanks.